Welcome, everyone. We are here for day 8 of the free Go Cloud Careers AWS Solutions Architect Certification 2024 program. And this is to prepare you for the AWS Solutions Architect Associate certification. And of course, we've covered much, much more. We added a lot more services in the artificial intelligence and machine learning space. We added a lot more security, which would have come out of the AWS Security Advanced course. We've added a lot more content out of the AWS Advanced Networking to give you a fuller picture of how these pieces and parts work together and how to make them more stable and more secure. So I hope you are all having a good time. Welcome back. I am thrilled that you are here. So let me know where you're from. I see some people in Nigeria, which I love, Cameroon, which I love, New Jersey, Jersey City. I used to work in Jersey City, actually. Ghana, I love it. I know Derek super well in Atlanta. I am so thrilled to see you over there today. I've got people in Cape Town, South Africa, people in Baltimore, Maryland. I love this. I'm pretty sure we have some other countries represented as well, which is always great. And we'll be begin in a few minutes. But let me tell you about a few things. Okay, New York, which is great. Worked at One Penn Plaza for a while with Cisco's headquarters in New York City. And did a lot of designs for banks over the years, both in Jersey City and New York City. Turkey. Oh, that's a great place. I haven't spent a lot of time in Turkey recently. My family lived in a place called Bedamos, Turkey. So lots of time I've spent in Turkey, which I've absolutely loved. And IDM in Nigeria. That's fantastic. I see Adrian's over there in Phoenix. So Seattle, Sacramento. So we've got a good part of the world represented today, which I absolutely, absolutely love. If any of you are from Greece, that's great. Tell me too, because I always love seeing other people from Greece. And I know there's lots of Greek people that typically follow our channel because periodically I go and speak Greek. But that is neither here nor there. Welcome, everyone. So before we begin today, I want to let you know about a couple of things that we have. And Kenya too. That's great. And even England. See, this is great. So we have some free labs for you to do on your own time. There's over 40 of them. So please sign up for them. Please do so. So you can get some hands-on experience. Now, tomorrow, we're going to have a couple of things to really help you, and it's all going to be free. We have our How to Become a Cloud Architect webinar from 11 to 1 p.m. tomorrow. And I got to tell you, that is a webinar you should come. It'll be on Zoom, so we can all have a face-to-face conversation. And not only can we have a face to conversation, we will talk about the role. We will talk about what we actually do. We will talk about the skills that you actually need, the certifications which will help you get an interview versus the skills that you need to be hired. We will talk about everything you need to know to be hired, including how to bypass HR so you don't get auto-rejected. And it's completely free. So we'll talk for 30 to 45 minutes, and we'll spend an hour and 15 minutes or more answering your questions live on Zoom. Now, in addition to that, if we finish the AWS course today, and I kind of think that we will, we're going to come around tomorrow afternoon, my team and I, maybe 2 to 4 or something like that. And what we're going to do is we're going to take questions on your career. Maybe you desire to be a cloud architect. We're going to cover that extensively in the morning program. Maybe you desire to be a cloud engineer, which is a completely different skill set than a cloud architect, or a DevOps engineer, or a network engineer, or a network architect, or an enterprise architect, or a security engineer, a defensive security engineer versus an offensive security engineer versus a security architect. We're here to take your questions, and we're going to do it free. I've trained people for the last 20 years that work at Apple and Amazon and Cisco and Microsoft and Google and IBM, Palo Alto, Zscaler, Accenture, Deloitte, KPMG, Capgemini, PricewaterhouseCoopers, JP Morgan Chase Bank, Barclays Bank, the BBC, you name it. If there's a prestigious organization, I've trained people there. So the morning session that we'll have tomorrow is how to be an architect. And in the afternoon, ask us your tech career questions, whether it's about architecture or other careers. I don't really care. I know what managers want. I've interviewed thousands of managers and executives over the years in terms of what they want. So when it comes to getting that first job or transitioning, it's about knowing you get the right skills that the manager wants, not what you think, because they're the ones who do the hiring. So I'll be here again this afternoon with some people from my team tomorrow afternoon, and we'll do career stuff, assuming we finish today. I see some more people in India. That's really fantastic. More in New York City. And fantastic. So now we're going to begin with infrastructure as code. We're going to talk about that today. I'm going to talk about what this means for you. So for example, if your goal was to be a cloud admin, once you see what infrastructure as code actually is, you'll understand why you probably want to start as an architect or an engineer or another position. Because what admins do is typically add usernames and password and click on boxes and deploy things and maintain them. And in this case, I want you to see why that's probably not a good place for you to be. So infrastructure as code, which we're going to talk about. And infrastructure as code is going to be the process of managing and provisioning the organization's infrastructure through a simple script. So instead of manually clicking things on the management console like you would be taught in a certification, here you've got one person that can develop a script, and they can launch thousands upon thousands of systems in a matter of seconds. And, it's relatively easy to write these scripts. You can honestly have AI even help create the base script for you, and I'll show you that just because I want you to think about the implications of that. So infrastructure as code is huge. It kind of supports, the DevOps kind of processes where we make an issue and we push large things out at the same time. It supports automation. So we don't have Nikolaus and Agilo Onospiros and Apostoli all try to set up the virtual machines and do them differently. So it's going to improve quality. It's going to reduce manual errors, and it's going to save a lot of time, which is one of the reasons organizations love coming out of their data centers to the cloud, because with infrastructure as code, they don't need as many people. So kind of keep that in the back of your mind. So how does infrastructure as code work? There is a simple text file that's basically created, and it's written by your infrastructure as code software, something like Terraform, and it will literally just push the configurations out. And that way, you can automate big changes. You can have a disaster recovery environment where you can basically launch all your tech in another cloud relatively easy. And truthfully, if you're using an OpenStack cloud or a Nutanix cloud, like so many companies are using, or instead of, say, a VMware environment, you could use infrastructure as code to add capacity locally in 2 or 3 other clouds in seconds. So it is incredibly efficient. Now, infrastructure as code uses some automation tools, and they typically come into basically 2 types. There's going to be something called the declarative and an imperative form. Now, the imperative approach basically defines a sequence of commands so that the infrastructure can reach its final result. Now, if any of you came out of network engineering and you basically created a little script in Notepad that would say config t, for example, and then you might put a host name for the router and enable secret and what have you, and you basically template out your router configuration and cut and paste it in, and your routers were set up. That's the way I always view the imperative approach, as a set of commands. Now, there's another approach called the declarative approach. And here's where you basically say, here's the end result of what I'm looking for. And the infrastructure as code tool goes and finishes it. So there's lots of infrastructure as code tools. Terraform is the one we typically think of that works across all clouds. Ansible is another option. AWS has their CloudFormation. There's lots of them. But if you're in a multi-cloud environment, you may want to use a multi-cloud tool. So the point of using infrastructure as code is it reduces costs. It reduces the amount of people you need, which reduces costs. It potentially improves the availability of the systems if the people that are using the infrastructure as code know what they're talking about. So kind of think about that. But if you don't know what you're automating and you automate it, you're going to automate it wrong. So never automate until you completely understand what things are, how they work, and why. I always loved infrastructure as code because it is consistent. And the key here is consistency is when a lot it's you don't have those variations between people. And if you think about various variations, that's where you've got a problem. This person didn't use a strong enough password. This person didn't use the right encryption. So if you know what you're doing and you're doing it well, it's going to be helpful and very helpful. So I want to show you what it's like. So you may have heard me talk about why I love architecture careers, and I just want you to all see this. I love architecture careers because we can't be replaced by AI as architects. The reason we can't be replaced with AI is we have to speak to businesses and ask about their business goals. We have to give presentations. We have to sell. We have to entertain our clients. We've got a lead team. So the architect can never be replaced by technology. If you're looking for an intro job, I suggest not. I suggest getting better skills and being an awesome engineer or an awesome architect or something. But I wouldn't look for those entry-level roles where you're going to click a bunch of boxes like an admin, because DevOps and infrastructure as code kind of relegates many of those jobs as unnecessary in today's world. Here's how easy it actually is to use AI to create an infrastructure as code script. So let's do one together, and I'll share it for you so you can see why I'm not why I'm always cautious, and I always recommend architecture careers versus, say, engineering careers. So let's say we wanted to create a Terraform script that launches 1,000 EC2 instances with 16 cores and 64 GB DRAM with 1 TB SSD based block storage drives. Now, I even made some spelling errors, but look what it's actually going to spit out so you can see it. It's going to tell you the type of system that it's actually using, and it's going to generate that script right then and there. Now, all we need to do is basically install Terraform, configure our credentials, and this is launched. And it'll even tell you, how to do that. So this is why, a lot of clicking on management consoles in today's world isn't going to get you very far, because in pragmatic worlds, infrastructure as code is going to be the way it's going to be done. So think about that. If you have a job where you have to present, if you have to speak, if you have to lead, if you have to discuss business, you cannot be replaced by AI. But if your goal is to do something like a Python script or a Terraform script or a Bash shell script, and one of those jobs where that's the core of the skills, understand they will still need people, but they will need the best of the best and the most senior and the most senior. So if it's your first job, you can still get a senior role. You just have to be great. So avoid the junior level, intro level roles and go for something more senior, because there's lots of great opportunities for you, lots of them. You just have to be great. And tomorrow's webinar on how to become an architect, we'll talk about how to be great. And tomorrow's afternoon career question and answer session, you tell us your goals and we'll tell you how to be great, so that the world will come to you and you'll have all the opportunities you're looking for. And we're going to do all those webinars tomorrow free. So let's talk about some AWS services, which kind of fall close to this infrastructure as code or either and that. So one of them is called AWS Elastic Beanstalk. And Elastic Beanstalk is a service for provisioning, deploying, and scaling web applications on AWS. Basically speaking, the developer uploads their code, and Elastic Beanstalk will automatically deploy the necessary infrastructure. So EC2 instances like virtual machines, containers, load balancers, and it's automatically auto-scaling. So if you've got a developer and they basically pop it into this, they can pretty much get their entire infrastructure built. So I kind of hope that makes sense. And Elastic Beanstalk is going to give you all the tools that are necessary. and then you'll apply it. So people that are using Elastic Beanstalk can write code for it in the following language: Go, Java, .NET, Node.js, PHP, Python, or Ruby. And this will automatically manage the environment. And if you choose to, you can auto-manage it thereafter or auto-tune it. So it's a code-like way to deploy your infrastructure. Basically, you stick in the code, it hits Elastic Beanstalk, and then it deploys, say, your web servers, your app servers, your cache, your database, your virtual machines, all of what you need based upon what you tell it. So that is an option on how to deploy things via infrastructure as code. Now let's talk about another application thing. And here we're going to talk about Amplify. And Amplify is going to be a service used for the quick development of full stack web and mobile applications. So you typically think of a full stack application as a front end, which is where the user is, and the back end, which is where the servers, code, and database is, and all the stuff behind the scenes that makes the app work. And typically speaking, for a developer to create these things, they've got to create their own virtual machines or storage, or you have somebody create them for them. But Amplify kind of makes it easier for that. So it's kind of like a browser-based visual development interface. And it enables, the developers to have this drag and drop configuration of their front end and their back end. And it provides this command line development, and all the magic happens in the application's back end. So it makes it real easy for people to create an application by just writing a few lines of code. And then there's Amplify hosting. So it can push updated applications to the internet. The code's typically received from a Git repository or an Amplify Studio interface, and it's deployed using AWS, and it can just be pushed to the system. We're kind of in that development and developer tools area now. So now we're going to discuss Cloud9. And Cloud9 is an integrated development environment, and it helps developers save time, as all the tools don't need to be configured separately that a developer might use, and they don't have to learn multiple sets of tools. So Cloud9 also has some automated code generation and intelligent code completion features. So intelligent code completion is kind of like when you use the new Microsoft Office 365, and it automatically finishes half of your sentence for you, and you just choose to accept it or not. So this type of environment makes it very easy for developers to write code. And, developers miss bugs too. And the more tools they have to catch bugs, the better the work output. Kind of like when you write a document in your Microsoft Word, right? And underline something in red, and then, to look at it, is the grammar right? Is the spelling wrong? What did I do here? So that same kind of thing. These tools help developers have a better, more organized workflow. The key to remember here, it's a cloud-based development environment. So it can be accessed from any computer with an internet connection. So often developers would create multiple virtual machines to have a separate environment. Here they don't need it. They just use this environment. Is that better? Well, it depends on your developers, depends on the kind of system they have, it depends on their sophistication. So it's an option. And the key is it's a pre-configured environment. So all the typical essential tools people would use, all the software development kits, support for script languages like JavaScript, Python, PHP, Ruby, Go, that kind of stuff is there. So it basically provides a terminal with pseudo privileges, and you could install additional tools, but it's pre-made for you. Again, you could just make a virtual machine sitting on your computer and then push it down when you're done, or you can use something like this. Cloud9 tends to foster a collaborative environment. And the key is you can take this development environment and share it with the rest of the team so they can collaborate. Much like a Google Documents or an Office 365, where you've got lots of people that can work and edit a document together. It's also serverless. So it integrates very nicely with Lambda, and it enables you to really test your serverless applications. So it helps with serverless deployment. It supports the AWS serverless application model for building serverless applications. And it's deeply integrated into AWS tools, whether they be things like code commit or code pipeline, some DevOps type tools, or AWS CloudFormation, which is the AWS proprietary version of, say, Terraform. And it's very easy to manage your resources with the built-in toolkit. It's highly customizable. So you can customize your development to suit your preferences. So where might people use Cloud9? Commonly with web and mobile development. It's going to take advantage of pre-installed tools for and development kits. It's serverless, great for serverless because it gives you an opportunity to test things like Lambda functions. It helps with streamlining the debugging tools. It's great for collaborative coding because it's just like that Google Documents kind of thing where you can see what people are doing, and that's kind of helpful. It's also kind of nice in a learning and education environment. So if you're teaching somebody how to code and it does word completion for you and it helps you along the way, this could be a useful tool for something like that. So how do you use it? Well, basically, you go to the management console and you navigate to Cloud9 and you click Create Environment. Of course, you got to name the environment and a description environment, and you do so. Then you configure the environment. Choose whether you want to create virtual machines for your environment or connect to an existing instance. You select the type of instance type that you're talking about. You set up the environment and it'll open it up in your browser. And right after that, you can start coding immediately and use any of the pre-installed tools. You can test your code with it. You develop it in there and you can test things in the terminal. And of course, you can collaborate with your team. And so let's talk about some best practices with Cloud9. You want to optimize the configuration. So choose the right type and size of your development instances for custom performance. Now, again, if this was on your desktop, you can basically, with your desktop, if you've got extra CPU cores and extra DRAM, you don't need to pay for any of this. So it might make sense to spend a couple $100 extra on your users' tools and not have to pay for any of these things. But it's an option. And it's an option where you don't have to be very sophisticated, which is good. And it's an option to do it and do it quickly. So there's times and a place for this. The collaboration piece is great. Now, when you're using a development tool or any tool, you should secure it. So at bare minimum, use IAM roles and policies, enable encryption at rest, and make sure your environment is secured, what have you, things like access control, security groups inside of your systems. Collaborate. If you're going to use a tool like this, and you're going to pay to use a tool like this, as opposed to creating a virtual machine on your desktop, please collaborate with others and make use of that team building environment. And of course, manage your environment and shut things down because, you have these systems. Well, they're great at configuring serverless. They run on systems, right? So you're going to pay for that system. So make sure that it makes financial sense. Okay, now we're going to talk about the AWS Infrastructure as Code tool. And that's AWS CloudFormation. And AWS CloudFormation is an Amazon-branded, Amazon proprietary infrastructure as code tool for delivering things using infrastructure as code on AWS. So it's going to be just like Terraform and CloudFormation. Here's a good use of it. It enables you to template known good configurations. For example, you've got an application that requires a bunch of servers, a specific set of packages installed, and patches. With CloudFormation, you could deploy a whole bunch of them with a simple script. So it enables organizations to provision their applications in a safe and repeatable manner. And it comes with AWS. And it's a great, great, great tool. But imagine you're on 2 different clouds or 3 different clouds, like 98% of businesses. Do you use a different tool for each cloud, or do you use one tool that'll work on all clouds? So these tools become very limited in the real world where 98% of organizations are multi-cloud. In practicality, it's an awesome tool, but we've got to use the right tool for the right job. So basically speaking, you create your infrastructure, you code your infrastructure, you upload it to object storage, and then you run the script, and then all of a sudden your resources are deployed. So I'll show you, we could write a CloudFormation script with AI, and there's other tools that are even better for coding than ChatGPT. In some cases, ChatGPT is a good all-around tool. But if we wanted to do this, and this is why I say architecture careers are going to be some of the best, because you have to talk to people, you have to lead people, you have to sell, you've got to present, you've got to do all these things which you could never be replaced. But on the engineering side, it's not quite as easy. But you can still keep jobs and get great jobs in engineering if you're great. And we'll talk about how to do that. Create a CloudFormation script. Maybe I should put AWS just in case. To launch 500 EC2 instances with 128 cores and 2 terabytes of DRAM with 1 TB IO2. Hopefully you'll see this. With 10 IOPS. So you can see what it's actually giving you. It's telling you to create an auto scaling group. You can see that it's naming this. It's telling you how many systems to use. Now, granted, you'll have to change the subnets to actually make it accurate. And you can see that it knows which systems to use by the 128 cores and the 2 terabytes of DRAM. And you can see that we spec'd out 1 terabyte with 10,000 IOPS, which is going to come from an IO1 or an IO2 device. We asked for IO2. And that's pretty much it. So you may now see why I say these admin jobs, we're going to go click boxes, that we don't need them anymore, because, we can have somebody with limited skill actually use this and create it and then tune it. But architecture jobs never go out of style, because they're all about talking to people and leading people and solving business problems. So there's there. So we'll talk about tomorrow, again, how to become an architect. And in the afternoon, we'll talk about, if you want to be an engineer, these are the skills that make you irreplaceable. These are also the skills that can add an extra $100,000 or $200,000 to your annual salary. So we'll talk about that if you ask questions about it tomorrow, because I want to make sure that everybody has a job they love and knows how to get there, because I've loved my tech career. So let's talk about some extra features of CloudFormation. It's easy. You define your infrastructure in a JSON or a YAML type template that you would use for, say, Kubernetes, and it's done. You've got version control alongside your application code. It makes it so easy to automate provisioning of your systems. You create a stack, you update it, you delete it. So just so simple and elegant and efficient. As far as it helps you handle dependencies, so it can handle the dependencies between certain resources to make sure that they're created in the appropriate order. If any of you guys are familiar with like the critical path and project management, where some things have to happen before something else. For example, you need the network before you put the servers on, because if you put the servers on before the network, they won't be able to get on the network or talk to each other, and nothing will happen. So network first, server second, that kind of thing. It enables you to roll back. So you made a new configuration change and it's bad, roll back to what worked before. It's also quite good to detect what's called configuration drift. So you may notice that there's a difference between what you see in your environment and the actual template. CloudFormation can help you detect that. It tends to be fairly extensible. And what I mean by that is you can create custom resources to extend CloudFormation's capability and make it support resources that are not natively supported. You can use Lambda functions to perform custom actions during, say, your stack operations. It's used in a lot of environments. So automating your provisioning of your infrastructure. Just asked it to launch 1,000 virtual machines of a specific size with a certain size IO2 hard drive from the EBS VMs. That's 1,000 of them. Imagine how hard it would take you to go to the management console. Click, Wait for the screen to refresh. Click, 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 click. Now, in the old days, do you see why we needed a lot of admin people? Because clicking all those things and waiting was taking forever. But we can now do in minutes what used to take 10 people, a week or two to do. So think about that and the implications of that for your clients and for your career. Where do you want to be? Be on the side where you cannot be replaced. So you might deploy a multi-tier application here, and you can manage the entire lifecycle of the application with infrastructure as code. This is phenomenal for compliance and auditing purposes because you just look at the script and you kind of know what you have. You can trap changes. You've got an audit trail. It's elegant. How about disaster recovery? So seriously, think about this. You've got all your information in one cloud because doing disaster recovery to another region in the same cloud is crazy. Because if it's in the cloud and the cloud has a control plane, a network failure, or a hacking event, it can take down the whole cloud. So if you're on AWS, you might have copies of your virtual machines and data sitting in Azure. And all you need is not a CloudFormation, a Terraform script. And you could launch your Azure systems instantly with the data that you have and be up and running in a very short period of time. So in this case, we're dealing with AWS CloudFormation, and we can use it for disaster recovery. We can launch systems. Maybe we've got our systems in Azure, and we use CloudFormation to launch them in AWS. So what goes into this? Well, you've got to create your CloudFormation template. So that means defining the resources using a JSON format or a YAML format. We create a stack. So we might go to the management console and navigate to, say, CloudFormation and create a stack. We'll upload our template file or specify a URL for the template. We'll provide any necessary parameters, and we will create the stack. We will then monitor the stack in its creation, make sure that it works. We will then update the stack, and then, when necessary, we'll delete the stack when we no longer need the resources. So some best practices with CloudFormation is to use parameters and output, meaning utilize parameters and custom stacks to make it customized for your environment. Create fairly modular templates. And what I mean by this is break down your templates, complex templates, into small reusable templates. And that way it's easy to tune things. Typically, you want to use nested stacks to organize it more effectively. Make sure you have good version control. So store your CloudFormation templates in a version control system like Git and track those changes so you can collaborate with key members on infrastructure as code. Okay, next we'll go to the Cloud Development Kit. But you know what? Let's see if anybody has some questions with what we have seen. I saw we had some few people. I saw Jawad coming in from the UAE. That's great. I actually set up the first fiber to the home project voice data and video in Dubai Marina in 2000. Or is it 2001? It was one of the first in the entire world. Had a great time over there. See who else is over here. Since we found out where you're all from. And I saw we had Ghana. Fantastic. Okay, Tyrone, you can bring in some questions. What about Terragnot? So we can use any tool that we absolutely desire. So I never have any problem with anything. And what we're really dealing with that is it's a wrapper around Terraform. And that's going to reduce repetitions and configurations. It's going to help manage, the remote state, and it handles, multiple modules. I have absolutely no problem for that or anything that you do. So I want you to think of one quick question and think about it in your career. So when I started my career, I worked for a Cisco competitor. And they had one of the best product sets in the world. But we lost almost every deal. And we lost every deal for almost two reasons. One is the Cisco people talked about business transformation, and we talked about tech. And customers don't care about the tech. They care about what the tech does for their business. But there was another thing I heard all the time. And we would go through a test off and prove that maybe we had a great architecture, we had a good solution, and they would still buy Cisco. And Superior, what they used to say is they said, nobody ever got fired for buying Cisco. And I said, what do you mean? And they said, Mike, if you're a chief information officer and you look at the available technologies and you pick a market leader like Microsoft, IBM, or Cisco, if it doesn't work, you're okay. And the reason you're okay is you chose the leading brand. And that's what most businesses do. And if you chose the leading brand and it didn't work, you didn't do anything reckless. So think about that. Now, any kind of technology that you choose is right is fine, but you've got to be in a position that says, here's why we made these choices. This is what this one software package or hardware packages does uniquely other than the other. And then if it's not the thing that everybody thinks about as the number one player or the number two player, when it breaks, and everything will break, but when it breaks, you're going to be saying, why I chose to use the thing that's not used in 99% of all businesses or 89% of all businesses. And that is a bad position. So it is great. It's just a wrapper for Terraform. And there's no problem using it. But always think about that with every choice you choose. Okay, let's see. What about CrowdStrike locking up desktops? So that's a good question, but here's what you need to think about. And I can tell you why this occurred too, according to Microsoft, and I believe it. So when you own your infrastructure, you have complete control of it. When you go to somebody else, you are at their mercy. So for the character at Google that misconfigured BGP and took the Google Cloud down for hours, you're down if you're on the Google Cloud because you are their partner. How do you deal with that? Put yourself in two clouds versus a single cloud, and you don't have that problem. And don't use these proprietary tools. Now, when you deal with other companies and patches, normally an organization gets a patch, they test it first on a virtual machine, then they test it in a development testing environment, and then they push it out. And then they deliver it to a small percentage of the users, and if it works, they deliver it to the entire set of users. That's the way you do change control and don't have outages. You also update these things at a time where the business is not busy. Now, the systems that were using CrowdStrike were letting themselves be auto-updated instantly without even being able to test it. So that means you are at the mercy of CrowdStrike, their intelligent development processes, and their intelligent testing processes, which you could see some major failures there. So there's a problem. Now, the reality is CrowdStrike kind of is at that kernel level in Windows. And the kernel is the head part of the operating system that manages your memory, etc., like that. So normally speaking, you would not expose your kernel and the security parts of your kernel to anybody other than the people that made the operating system. So when you buy a Mac, stuff doesn't go at the kernel level without you approving it first. It's not going to be automatic. On Linux, things don't go at the kernel level automatically. They're blocked. Now, the European Union went out there and was looking at suing Microsoft for what they called unfair business practices. What unfair business practices were for Microsoft was not allowing people to develop for that kernel. So Microsoft said, well, if we have to do business in Europe, we have to comply to European laws. We're going to open up that kernel. So the European government forced Microsoft to go open a hole in the most critical part of the operating system. And then when CrowdStrike pushed out an update, which it didn't test properly, and the Windows systems were open because they were mandated to be open by the European government, as opposed to necessarily what was right or wrong for the operating system, it enabled that to occur. Now, do we blame the European government? Well, their goals were good. They wanted more people to be able to write security stuff for Microsoft than the Microsoft itself. That seems reasonable. And it wasn't that it was irreasonable based upon what the goals were, but the people that were thinking about openness probably weren't thinking about security. So anytime you try to force something to occur, and any architectural or technology decisions you make, everything that you do is good is going to break something else and be bad. So architecture is not about choosing the great technology or the best. There is no such thing as the best. It's like a medication. You choose the right tool for the job that you need after evaluating all trade-offs. I use this proprietary tool. Okay, it's easier for me to use, but it costs me this, this, and this. But in our business, the speed and agility is worth a proprietary tool. Okay, go ahead. Now, when that's wrong years later, you can fix it, but at least you had a reason for doing it. So the key is, should we allow things to be open in a system like that? The answer is no. But if the governments around the world are forcing it, what can you do? And this is not the first time we've had a major security outage, and it will not be the last time, which is why don't use just one security vendor. Use 2 security vendors. Don't just use a single cloud. Use systems. And for example, when we made traders and trader systems, trader A would be plugged into one part of the network and trader B would be plugged into the network. And they were next to each other. You could tap the person on the shoulder. And why do we do that? Because if I'm here, the trader Mike, and my system goes down, I go over there to trader Sally and say, Sally, please place my trades for me. And we salt and peppered, as they like to call it. Each user was on a different network. And by doing so, we could lose half the network and the users would still be good. So same kind of things we're talking about here. Should you use LAML and CloudFormation or copy and paste from AWS documentation is enough? It depends on your job. If you are a cloud architect or a solutions architect or AI architect or enterprise architect, there's not going to be any CloudFormation or infrastructure as code or touching the technology in your job. It's not a valuable skill. If you are a DevOps engineer, you better be really good at this, because this is going to be a big percentage of your job. If you are going to be a cloud engineer, you better get pretty good at this as well. And, there's going to be that. Now, should you read the vendor's documentation prior to doing anything? Absolutely. Absolutely. So you should always read the documentation, because commands change over time. But you're really going to need to know what you're actually doing when you're doing this. And you're going to need to know if this is one of your jobs. So the key is really figuring out what job you want and then being great at the tools that you need. So tomorrow morning, we'll have that free thing on architects. Tomorrow afternoon, we will talk about other, other careers if you want. Ask us any way you want to be great at your job. And, maybe your goal is to be a distinguished engineer. We can tell you how to get there. Maybe you want to be an architect. We can tell you how to get there. But all these jobs are different and they need different skills. Derek, can I explain the GitHub repository check and check in and check out process? Well, yeah. So checking out is really going to be cloning what's in that repository and pulling it. And checking in is going to be adding it to Git, kind of a Git commit, as they would call it, or a Git push. Now, to be fair, Derek, I'm an architect, and we don't really use Git in our careers, but people that are in that software engineering world or DevOps engineering world, or potentially even some cloud engineers, will definitely be using GitHub repositories. Any other questions? All right. If not, we will get back to the content. So if you haven't accessed any of our free labs, please go download them. They're completely free. My team also wrote a certification guidebook for you as well. I'll pop that in the chat box. And maybe you want to know how to become an architect and you're curious what certifications are going to make you look good. Well, we wrote that book intentionally for you. For example, if I see a SysOps certification on an architect, I tend to be inclined to walk away. The same way, if I had an airplane pilot and they didn't talk about having fancy flight things, but they talked about law school on their wall, I'd be inclined to walk away because I didn't think they'd be a full-time pilot. But if they had pilot thing, if they were a lawyer and they had law school, law this, law that, law the other thing, I'm going to say this guy's or girl's great. So same thing with your brand. You can build them in alignment in your career, or you can get them in 10 different people's careers and show yourself. It's like you're a little confused, and show yourself as an entry-level person in a lot of different careers. Or you can build a serious portfolio, learn something, and show people you're great. So that documents on how to show people you're great, because it's hard to do this work. It's hard to get certified. But unfortunately, if your goal is to be an airplane pilot and you got a certification in nursing, nobody cares. Nurses are critical, super important. But being licensed in nursing is good if you want to be a nurse. It's not good if you want to be an airplane pilot or an attorney or something else. Same thing in tech careers. So we're now going to talk about something called the AWS Cloud Development Kit. And actually, let me know you're here by giving me a hashtag AWSSAA. If you're learning something, hit the like button, please. Subscribe to the channel. Hit the bell to be notified of new things to help you in your technology career. So let's talk about the AWS Cloud Development Kit. It is another infrastructure as code tool offered by AWS. And it's an open source software framework that's for use for managing AWS-based infrastructure. And it makes it relatively easy for developers to define cloud infrastructure in those familiar programming languages that they tend to use. And that could be Python, that could be JavaScript, that could be TypeScript, C#. So instead of building, your cloud infrastructure using the graphical interface in this or the command line, here you're doing it programmatically using the Cloud Development Kit. Lots of tools do lots of the same things. So it provides kind of this high-level object-oriented abstraction, and it enables developers to create a cloud infrastructure as a set of reusable code. And they call those things constructs. And these constructs are combined together to form stacks and applications. And then you can deploy these stacks and apps in your infrastructure by using a CloudFormation template. So you can look at it kind of in this environment where you've got this cloud development application. And you can see how it gets compiled, turned into a CloudFormation template, and then launched. So it's a pretty interesting way to do things, but there's lots of environments for infrastructure as code. So why might you use the Cloud Development Kit? It tends to make onboarding fairly easy because it helps developers roll out applications even easier. It enables developers to kind of customize those constructs that we talked about to meet an organization's, say, security needs or compliance needs. Now we're going to talk about another application development tool called AWS Code Artifact. An AWS Code Artifact is going to be a managed artifact repository service that's going to make it easy for organizations to secure, publish, and share software packages that they might use in their development practices. So it's going to support common package managers and formats. So makes it relatively easy and versatile to manage dependencies across different programming languages. So there's some features that you would think about with AWS Code Artifact. It's going to be a managed artifact repository. So by having a repository and an artifact as a piece of something or a creation of something, you can put it there fairly easily, and it scales to meet your needs. So you don't have to think about where you would store it and how you would store it. It takes multiple package formats, so you can think JavaScript, Python, Java, .NET. So you can put lots of packages in a single repository. And then you can use access control. So you can use your identity and access management policies. Nikolaus can access. Peter cannot. Costa can, based upon their job roles, for example. And of course, it supports encryption using the AWS Key Management Service. Helps you with version control and dependency management. So it can store multiple versions of a package. And that makes it easier for you to think about and roll back to other packages that may have different dependencies on other packages. So if you're familiar with Linux, for example, and you want to install this application, but this application is dependent upon 10 other different packages, and you have to install those packages before the application will work, that's really what we're talking about to make this helpful. So helps with version control, versioning as well. Now, if you're dealing with the CI/CD, this kind of continuous integration, continuous deployment pipelines, it's going to be very seamless. And with those other tools that we're going to talk about, code pipeline, code build, and other CI/CD tools. And that way you can kind of automatically build in some of the deployments using images or the packages that you stored in code artifact. It tends to be very compatible with other artifact repositories and package managers. So makes it easy to do proxy requests and cache information from public repositories. Why would you use something like code artifact? Well, package management can get fairly complex. And of course, you could store a folder on a file server and put your packages and put your dependencies in there and create multiple folders. You could with a really good naming convention and have no problems. But in a big environment, you got people writing code all over the place. Do they adhere to the right naming convention? And if they don't, do they create the right folders? And how hard is it to find stuff in the versions? Well, it can get ugly if you don't have good practices. So here's a tool that would make it easier for organizations that don't have the best practices to be able to do this in a repeatable way. And honestly, anytime you make things easier and people can make less mistakes, it's a good thing. Great for managing the dependencies of multiple projects, because managing systems and the package dependencies can be kind of ugly sometimes. It can help a lot there. You might want to use code artifact for secure package distribution. And that's great. You can basically encrypt your packages. And of course, you're going to use this from a use case perspective, integrated into your CI/CD pipelines. So how to basically use this? Well, you go to the management console and you navigate to code artifact. And you're going to create a domain and a repository. The domain is kind of this big area, and you can create multiple repositories in there where you store stuff. You'll then configure your package managers to use the code artifact repository. Then you'll publish your packages to code artifact. And then basically you can install packages as needed from code artifact from the package manager. Now, some best practices associated with something like this are to use strong identity and access management controls. Really use that role-based access control where you've got good roles and good permissions for each roles, and do it efficiently. Create versions. So versioning is good. Versioning will make version 1, version 2, version 3. You push out a new version, it's bad, you roll back to the other one quite easily. And you can see this. People that were using Nutanix systems after the CrowdStrike thing, they had an easy way to roll back to the original systems without that update, and they were and some of their customers were up and running soon. So versioning, or any kind of versioning, can be highly beneficial, and it can be a good checks and balance for someone else. So of course, if you're going to use this tool or any other tool, you need to monitor it. So enable logging and look and use CloudTrail. So monitor CloudWatch, look at those CloudTrail logs, track usage and access to your repository. Imagine if the wrong people are getting access to your proprietary software and applications. That's not good. So integrate it with those DevOps pipelines to automate building and deployment. And make sure that you cache dependencies from any kind of public repository, because you may have something that you're constantly pulling from a public repository and it might not be there. It could be down for a little while. So you want to cache that information to make sure your development teams have access to what they need when they need it in a fast and efficient manner. So now we're going to talk about another application development service from AWS, and that is Codestar. And Codestar is going to be a service that's going to assist in creating, managing, and deploying software applications. It gives you a central console that you can use to assign project team members and the specific roles they need to use, and being able to people to access tools and resources that are needed through the centralized console. So basically, Codestar gives you a single dashboard that integrates software development tools, and that's going to make it easier for managers, developers, and people on a team to collaborate. And they can use the console to track software developments from week to week, task to task. Let's talk about AWS Device Farm, another application development thing. So that's going to be a fully managed service to help you guys test web and mobile applications. So it enables you to improve your applications by running the tests on real devices, if you will, by simulating real world environments. So realistically speaking, that's Device Farm. And it enables automated testing because what you can do is you can select the code that you wanted to test. Then you select your devices. So you want it on a virtual iPad, it'll run on a virtual iPad. And you can tell it the iPad operating system version, for example. And you can select as many of those virtual devices you run, and they're running the actual software of the physical device. So you can push content on a bunch of applications, you can on a bunch of virtual systems, you can test them, and that way you can interact with remotely. So here's the thing, it gives you the ability to give a full wide range test on real iOS or real Android devices. Now, they're not physical devices themselves, generally speaking. They are virtual devices, meaning they've got a virtual CPU, virtual memory, but they run the full operating system. So it's going to feel kind of identical to the physical thing. And the only time it won't work is if you've got a hardware problem on the real physical device that it doesn't know about in the testing environment. So that's going to be something else. So you may use Device Farm for testing, and then you're still going to test it on some physical devices when you give it to the user, but it gives you a great environment to test it on. And Device Farm supports automated testing tools. There's lots of them like Calabash, Espresso, there's an XC test, there's others as well. So you can run automated tests without modifying your test scripts on these virtual devices. Of course, you can do manual testing as well, directly through your web browser. You can manually test your applications, debug them, get screenshots. And again, this is going to integrate into CI/CD pipelines, which, the concept of constantly improving your software and pushing software out faster is great, right? But if we push the software out faster without testing it, like that CrowdStrike issue, we can have big problems real fast. So it's not always, you don't always want to speed it up. You want to go as fast as you can while maintaining quality, not just push. So always think about that. So where would you use AWS Device Farm? Typically speaking, to make sure your applications are going to run on a variety of operating systems, devices, and screen size. So you can push it on this phone, and see if it's going to work. And because you can use like a virtual CPU and virtual DRAM that's going to give you the very similar performance to the real thing, you can do some good testing on it, including performance testing. You'll be able to test web apps on the various browser versions and devices. I'm sure you've seen websites where you tried to use Google Chrome and it doesn't work well, or you've tried to use Safari on Mac and then they tell you got to use Microsoft Edge or Internet Explorer or something like that. Not Internet Explorer these days, but there were lots of applications that were written that would only work in one browser because they never tested or coded it appropriately. You might want to use it for regression testing, which is a type of QA testing, to ensure that new code changes don't introduce new issues. You can make sure that it maintains the stability of the applications people will be using. You can use this for beta type testing. Test it on these real virtual devices and then give it to people physically to test it on their physical devices. So how might you use Device Farm? Well, you basically set it up by going to the management console, navigating to Device Farm, and creating a new project. Of course, you'll name your project and configure its initial settings. You'll then upload your application, and Device Farm will help you analyze the app and prepare it for testing. Then you'll create your test suite, and that's you'll choose from a variety of tests. There'll be lots of tests, for example, and you can introduce built-in or custom script-based tests, and you configure your test suite to match your technical requirement. Then you'll select your devices. You want Apple devices, you want Android devices, and then you run your test. Now, you can do what's called parallel testing here, and often you're going to want to from a best practice perspective. So run your test on lots of stuff at the same time. Reduces your testing time. From a best practice perspective, create custom device tools. So Focus your most of your testing efforts on the systems you use the most. I've got a friend that's got an iPhone 5 still. If I'm writing code, I'm not going to do a lot of tests on an iPhone 5, even though it's an antique at this point, and my friend likes it just because they like it. We're going to test it on stuff that's actually modern, that the preponderance of our users are on, which, let's face it, if it's desktops, the preponderance of our users are on Windows, because the business applications that people use don't typically run well on other operating systems because they're not built for it. And that's why most business applications and businesses run on Windows. Servers, by comparison, most run on Linux because most server-based applications are hosted on Linux. So it's not that one's better than the other. You've got to use the right tool for the job. But if you've got 3% of your users that are Linux users and 97% of your users are Windows users, you spend the majority of your testing time on the Windows users. Same thing here. You look at your most relevant devices and you push most of your testing time there. From a best practice perspective, definitely integrate it with your CI/CD thing. So whether you're using CI/CD tools like Jenkins or CircleCL or AWS Code Pipeline, make sure you integrate it there. Analyze the testing report. So when you test stuff, and you should test stuff all the time, make sure that you have good test reports. Log your tests. When it comes to testing, your testing scripts have a lot to do with how efficient your tests are. So make sure your tests are efficient, reliable, and provide meaningful results. All right, so we cover that application perspective. And let's talk about Amazon Proton. So at the end of the day, Amazon Proton is going to be a managed application delivery service for developers and DevOps team to help automate and manage infrastructure and infrastructure provisioning. So it enables the developers to define a version, a time, and distribute their infrastructure templates. And that way they can have a templated infrastructure as code type standardized approach for their applications to be deployed. Proton supports what's called template management. So you define the infrastructure as code using an AWS CloudFormation template. It gives you nice version control and good updates and rollbacks. And that's going to support both environment and service templates. It helps with automated provisioning because it's infrastructure as code. So, let's call a spade a spade. Proton also tends to integrate nicely with CI/CD pipelines like AWS Code Pipeline, Jenkins, or GitLab, the more tools which are more multi-cloud kind of environments. It helps with monitoring and notification. It integrates well into CloudWatch, and it supports SNS notifications. So you can run this thing, you get CloudWatch events and logs, and you can get little push messages as necessary or text messages to tell you that something is going on. And it can help support security and compliance because it'll enforce security best practices through the predefined templates. And that makes it very easy to provide some role-based access control, like systems administrators can access this versus sales reps can access this. So how do you use Amazon Proton? Very easily. You define the template. You define the infrastructure configuration parameters and your deployment scripts. You publish templates to the Proton service catalog. Basically speaking, you upload your templates there, and then you use version templates to make sure that you manage your updates in a single place. You create the environments and your services. So you go to that management console or CLI or software development kit, and you create the environments and the services based upon your published templates. You'll configure any parameters specific to your application's unique needs. And then you deploy your applications. And Proton will provision them for you in an automated manner. And you can monitor the deployment status and through the logs on the Proton dashboard. And like anything else, there's a life cycle of this, right? So we'll use Proton to update it, scale it, and manage throughout the life cycle of our applications. And if we've got a bad one, bad code, we push it out and we roll it back. So let's talk about best practices. Design modular and reusable templates. If they're modular, One of the reasons people use microservices, for example, is they might have the service that's going to be redeployed in 50 different applications. And that's where microservices helps. And that makes it easy. We've already got this stuff, this stuff, this stuff, and this stuff, and this stuff pre-made. Now for this microservice application, we only need these things. Now, obviously, in microservices, if we don't have a lot of reuse of our services, it creates unnecessary complexity and no benefit. But if we're Google and we've got lots of applications and so many of them need this module, this module, and this module, it saves a lot of time, effort, and money. So it's all about the right tool for the right job. But going back to here, it's the same thing. We create our modular templates. And why am I drawing all these connections for you? I want you to understand when you got fundamentals are good and you understand it, it's the same thing everywhere. So hope that helps. Now we're going to create these templates and any kind of infrastructure as code. Add your security here. Implement the principle of least privilege using IAM roles and policies. Use strong encryption. And then implement monitoring and logging. And we'll talk about, because you want to make sure you know what's going on. And, monitor your costs. They'll tell you through Cost Explorer. I'm going to tell you, if you've got anything on the cloud, you need a FinOps team to truly look and see what's working and what's not working. And then we'll get into Amazon X-Ray. And, Yassine, you put in an incredible question in there. And I'll talk about the reality of tech versus what we think or we'd hope would occur. And that's why when we'll talk about it, when we go to next time, we'll talk about architectural considerations of what to expect, how to expect, why to expect, and when we get these types of challenges. So I'm familiar with X-rays. I've read a lot of them in my old life in healthcare. And X-rays give me the ability to look at someone's, what do you call it? The radius. And I look at the radius or the ulna, and I can see if there's a fracture there. Makes life easy for me. So I do an X-ray. Well, Amazon has a service that's going to help developers kind of look and see what's going wrong with their distributed applications, and it's called X-ray. So X-ray is going to provide an end-to-end review of requests that are going to travel through your application, and it's going to help you identify performance bottlenecks and troubleshoot effectively, just like a medical professional might use an X-ray. And X-ray will look at API requests. It will enable developers to analyze and debug their applications. It's going to give them a full picture of the requests and the way they actually occur. How does X-ray work? It basically collects data from the application and services and then aggregates that data into a form that's traceable for each application and service. So it'll create what you could call a service map, which is really just a visual representation that you can use to trace, debug, or troubleshoot each device. And the users can then fully drill down on each service to see the real root cause. So why would companies use this? What are some key features here? It's distributed tracing. So we've got a monolithic application. It's very easy to see where it's at. We know where it's at. It's simple. When we've got some of these applications that are little bits and pieces in multiple data centers, multiple clouds, it gets more complex. Microservices are a lot more complex than monoliths. And sometimes it's worth it, and sometimes it's the worst decision ever. But it's based upon the business needs. So we've got these complicated distributed systems. We need a way to look at it, and X-ray is a good tool that we can use. It's got a feature called service maps. And what you can do is you can generate these service maps that's going to show the relationships and dependencies between your application components. This thing, which is connected to this thing, which needs this thing, and this thing. And you can also look at your applications and you can see where you might have performance bottlenecks. And it's a very useful tool for this. It's also helpful for anomaly detection. So like an X-ray, it'll help detect anomalies and maybe your application's performance. You can set up alerts for extra latency, too much latency, or error rates somewhere along the place. And you can get some good insights. So how do you set this stuff up? Well, basically use the X-ray software development kits, and you use it to instrument your application code. And this works with a lot of languages like Java, Python, Node.js, .NET, Go, Ruby. And of course, you can integrate X-Ray with things like Lambda, API gateways, even like Elastic Container Service by turning on X-Ray tracing in the configurations. So then you deploy the X-Ray daemon. And typically speaking, on a virtual machine or a system, you have something called a daemon. And it's kind of this lightweight thing that runs in the background that collects data or does something. So you deploy that daemon on your systems. If it's a Lambda function, it's going to be automatically managed by AWS. But if it's on a virtual machine or something, you'll have to deploy the daemon. You'll enable X-Ray in your application, meaning tell the application, send information to the Amazon X-Ray service. And we will use that to create segments, sub-segments, and annotations inside of your application code. And then we will analyze the data. We'll look at the X-Ray console and the management console. What are we seeing? What do these traces look like? What insights do we see? And we'll use trace analytics and filtering features to search for what we want. Let's talk about some best practices with regards to Amazon X-Ray. Instrument it thoroughly. So make sure that any key critical path in your application is going to be instrumented with X-Ray because you want to get a comprehensive view of performance. Instrument both synchronous and asynchronous components to capture a complete flow of requests. Add annotations, add metadata. And you're going to do this because you're looking for certain things. And make sure you have as much information to provide business context information. So when you look at your traces, you're going to know something. This will help you filter and analyze systems much more efficiently. If you're going to use X-rays, monitor and alert. So set up monitoring alerts. So you see an anomaly in latency. You need to know about it. You're seeing lots of error rates on an API. You want to know about it so you fix it. So set up CloudWatch alarms so you can be notified of any kind of potential issues that are detected by X-rays. Really tune your performance and optimize it. So you want to make sure that the insights provided by X-ray will help identify and optimize performance bottlenecks in the application. And we're going to focus on high latency segments with error rates, for example. So the next one's going to be an odd one, but I'm going to talk about it, and it's called Amazon Pinpoint. Now, Amazon Pinpoint is going to be a flexible marketing communication service provided by Amazon. So lots of time businesses have an email list. And you see an enterprise and they may have millions of clients on their email list. And they need software to push it because you can't manually have one person going email to 10 million people. I mean, it would be fun, but it just doesn't scale. So there's lots of tools that are out there. There's major packages that are out there in the marketing world. There's lots of companies that do this. But Amazon threw their hat in the ring to have something that can provide email, SMS, push notifications, voice message systems, what have you. So it's used to send targeted email campaigns. Businesses will have multiple email lists. These people want security, so you send them security information. These people are interested in fitness information, so you send them fitness things. So this supports it like any of the many other industry players which own this space. But this is an Amazon tool that does it. Can deliver SMS messages for marketing campaigns or notifications. Can send push messages to your mobile phone. And isn't she cute? That's my little cat, Cindy. She's that's my little baby girl. But neither here nor there. I like my cat too much. But you can even send voice messages to customers. Now, one of the key with marketing, anytime you market, is you have a segmented market share. Because not all customers are interested in the same things. For example, sending my wife outdoors person information about big packs that you might carry and how to drink, water using a special straw that filters it out of the lake so you don't have to boil your water. That would not be interesting to her. Prior to my foot injury, that would be great to me, and I would go buy lots of packs and life straws and MREs to keep around the house in case there's a hurricane and there's no power, because that's me. But they send me what I'm interested in and send my wife what she's interested in, which is usually shoes or something related to shoes or medicine things, because she's incredible at cardiology and internal medicine. So this enables campaign management, so a business can design and schedule their campaign message across different channels. They can have a trigger, sign up, get this download like you can any other commercial email package. It can enable you to personalize messages. So instead of saying, hi, you, it could be hi, Mike in the messages, like any other good marketing software package could do. And just like any of the many, many commercial email and SMS software packages out there, it can provide analytics and reporting. So you can track, marketing campaigns with delivery rates, open rates, click rates, what have you. And it can also have something, it's got a feature called the Journey Builder. So lots of email campaigns can say step 1, step 2, step 3, or a user does something and that's how you send them information. So very common email package. Again, like other email packages, you can set up A/B testing to push 2 different emails or messages to see which one customers like more. It works with event-driven messaging. So user signs up for something, you can do it. Or how often do you go to a store and you're looking at something, maybe a backpack, an orthopedic one that's not hard on your back that you like to keep around the house, and you put it in the cart and you don't buy it. And then you get an email. You've got a message left in your cart. That's event-driven messaging. So how do you use Amazon Pinpoint? Well, basically you create a project. You define the segments, meaning like this segment, this segment, this segment, customer-focused segments. You define your marketing campaigns and you set them up. Then you send messages. And then you look at it. Okay, we sent out 1 million emails and 1% of the people opened them. Okay, maybe there was something wrong with the subject line. Let's do something else before we send it again. And then you optimize, and you optimize. Tyrone, let's take a break for a few minutes, see if anybody has any questions. And there were a couple of things in there which were really great questions that I thought we should address. Wait, I'm on the wrong window. While we wait for the questions to come in, to remind everybody, we've got free labs for you to do, lots of them, over 40 of them. My team will pop the link to those in the description of the videos as well as the chat box. Tomorrow, we have a free webinar in the morning. We're going to talk about how to get your first cloud architect job. What are those skills that you need to learn? How to bypass those HR people that auto reject you? How to go straight to the hiring manager? The certifications that are going to make your portfolio look good and more. And it's free. And it'll be on Zoom, so you can ask us any questions about starting your career. You want an interview from us, we'll give you a little mini interview, see where you're at. So join us tomorrow, and it's free. And if you're having a good time, like the video. Can I explain who should build an SDLC at an organization? So I want to make sure that I know what you mean by SDLC, because there's a lot of acronyms that mean SDLC. You might be talking about a software development lifecycle. So I'm going to work on that, but you might need something more because there's lots of SDLCs out there. So the key with the software development lifecycle is it's a team. And it's going to take a team of people to really create this stuff. And I am not a software developer by any stretch because I'm an architect. But let's typically go what goes into the cycle. We're typically going to have a project manager. And they're going to be the people that say, Joey, you got your code? Billy Bob, you got your code? Sally, did you write the documentation on this code? Mehdi, where's your code? So there's that kind of thing. So you'll also typically have the software architects, and they're going to be the people that design the application. So they're going to meet with people. They're your application architect. They're going to talk to the business owners, like the C-suite. They're going to ask about the goals of the business. They're going to ask about the business processes. They're going to evaluate the current applications and see what applications are going to be necessary to get that business to their goals. Architects don't code. Architects don't touch the technology. So, but they build the plan. Part of that team, you'll have your software developers. These are the people that write the code. They're your software engineers. And they'll be writing the code. And then you're going to have a QA team. And the QA team or the quality control team or quality assurance team, their job is to try to break your stuff. So in good organizations, you've got really strong QA policies. Many organizations have very weak QA policies. You may see a lot of developers on Google that say, on LinkedIn, just push your code, and if it doesn't work, you can test it later. Well, they terrify architects like me, but you see it all the time. So your QA engineers are the people that'll break it. You might want to test routing code on a virtual router. So an organization may launch 10,000 virtual routers in the cloud, and then they may use traffic generators to try to break it, for example, or try to see, push something to try to destroy a web app to see how far it goes. That's your QA engineers. Then you're typically going to have your DevOps engineers, and they're going to typically help, with the operations side of this, manage the deployment and the integration of the system. And of course, you're going to have your stakeholders. Stakeholders are going to be the business executives. They're going to be the managers of the departments. They're going to be managers of various business units. And your architects are going to be spending a lot of time managing those stakeholders, leading those stakeholders, negotiating between those stakeholders. And that's why architects, as a general rule, are never allowed to touch the technology. They're so busy managing stakeholders, managing vendors, leading teams, making sure that the business requirements are being met. So that's typically the way that team goes. That's a great question. And it needs to be sponsored by an executive team, because the executive team are the people that are there. What is the path to the CIO, NB? And that's a really great question. So first thing I want you to understand is CIO is an architect. What do I mean by that? The Chief Information Officer is the head person that sets the strategy on aligning the IT systems with the organization's business needs. So it is an architectural role. Now, because the CIO is the chief architect, and sometimes they're an enterprise architect that's called the CIO or CTO as well, we have to understand that they need a lot of executive skills. They need to be able to understand the business. They need to understand the business processes. They need to understand how that business needs to operate, the business goals, the business future. They need to understand all the way that organization connects to other people. They've got to manage the team. They've got to hire the people. And that chief information officer is going to have to manage the people or have the people working for them. So their chief information officer is going to have a lot of things that they need to do. So it's mostly an executive. So how do people end up as CIOs? Typically, and not always, they've got a business degree, because this is a business role. And I make it clear there are no certifications for executive roles. Quite frankly, there's almost no certifications for architects, but for that same reason, these are executive roles. There's certifications architects get, but they're completely unrelated to architects. They're related to different things. And we could talk about that at this webinar tomorrow. So there's that. So I could see going from a cloud architect to an enterprise architect to a CIO. I could also see taking a business person that's been a sales executive, and I've seen it for a vendor like Cisco, that all of a sudden is hired as a chief information officer. I've seen people that were IT directors and VPs of IT that are pushed into the chief information officer role. And I've honestly seen some very good non-technology professionals that moved into chief information officer roles and chief technology officer roles, where they basically were really good executives. And they built a team of highly strategic architects that focused on the technology design into them. And then underneath them, they had really good teams of engineers. So the key to this is business acumen. The more business you know, the greater you're there. And that's why when we train architects, we put so much business acumen into the training, because you can't be an architect without the business acumen. And the architecture is a transition role to the CIO role, the CTO role, a VP role. It's a great role, but that's typically the path. Now, could we get someone from engineering in the CIO role? We could. Here's what they would need to do. They would need to go from techie to non-techie. They would need to learn how to communicate like a leader, sell a vision, lead large teams, have lots of business acumen and executive presence. And typically speaking, when I've worked with people that come from a tech background, it's kind of like one of those movies where you do a makeover. You get the person out of their t-shirts or their golf shirts into an Armani suit or a Canali suit, put new shoes on them. You teach them a new walk. You teach them a new way to communicate, a new way to present. You work on getting the person perfectly polished white teeth. You work on that person and their social graces and coach them on leadership and development and sales and the ability to exercise influence. And that's honestly how you get into any of these roles. But great role. It is an architect role. And that's why architecture careers are so good for feeding the C-suite. Good question. What is the best antivirus to use in an AWS environment? So I'm going to first answer that question. There is never the best technology. Never. And the second you think there's a best technology, that's when all of your situations are going to fail. We have to understand the business use case. There are times when Trend Micro has the best solution in the world. There are times where McAfee or Symantec have the best product in the world. And there are times where others do as well. So we have to determine what the needs are because not every product performs the same way. So even though they're antiviruses, they all do different functionality. Which is better, a Lamborghini or a Ferrari? Well, I don't know. Which is better, a Mercedes SUV or a like a GLE 350, for example, or a Porsche SUV? Well, what's your goal? The Porsche probably performs a little better. The Mercedes will go 500,000 miles. What's your definition of better? I don't know. It's different than you need. You know, you might use a certain kind of car to create a limo out of it. You might use a different kind of car for something else. So you, in every single time you will pick a technology, you will have to look at your environment. You will look at the strengths and weaknesses of each and every application. And in your environment, because you may have one application that doesn't work well with any of these things. You really need to figure it out. It all goes back into the same way you would train a doctor. And I learned architecture when I learned medicine. There's never a best pill. Like, I don't have a favorite pill when I see patients, and occasionally I do as a volunteer. I ask them their condition, and when I know their diagnosis and their allergies and any other conditions, for example, this drug may raise somebody's blood pressure, so I can't give it if someone's got high blood pressure, but it could be the best drug at treating it in people with low blood pressure by comparison. So this is all about judgment. What's the goals? What are my opportunities? What are the strengths and weaknesses of each opportunity? And when am I there? So there's that. Other thing that I would caution you, there's no such thing as just an AWS environment. 98% of organizations are multi-cloud. So it's going to be more which works with your clients in their enterprise environment. If you can think about that and always focused on the goal. So here's how you innovate. You look at the end goal and then you work backwards with the tools. You want to build a house. You've determined the house needs to have 6 bedrooms, 4 bathrooms, and 3,700 square feet. You've also determined that you need to build it. Okay, so where I live, they need to make that house out of cinder blocks that are filled with steel and cement, and that's how you build the outside. Why? Because I live in an area where there's hurricanes. Now, to build a house like where I would live costs a lot more than to build it in another place that doesn't get a hurricane. Is the building style that I have in my approach better? No. It's better for Florida, but it might not be as good in New Jersey or Pennsylvania or Kansas. So it's all about choosing the right choices. Hope that makes sense. In the case where there's a new manufacturing company started, is it advisable to present an architecture for their IT infrastructure and operations, or should you wait to be called for? Well, you can't be somebody's doctor unless they ask you. So if you're starting a business, what are the goals of that business? What are the business processes for that business? How do they want to manufacture what they want? Do they have robots? Are they using AI? Is labor cheap where they're at? And they're going to use a lot of labor. What kind of tooling are they going to have? Are they going to do it via an assembly line where each person does one part? Or do they have one person doing the manufacturing process from start to finish? That needs to happen first. When you know that, then you can figure out what you need to do. Just like if you had to hang a picture on the wall, you'd first look at the weight of the picture. Then you would look at what your wall's made out of. Then you would look at what tools are necessary to hang that picture on the wall. Do you need some kind of thing that needs to go into the wall and expand out because it's heavy? If so, you would use it. What if the wall has wooden studs that you could drill directly into that? Then you wouldn't use it. So it's always going to be evaluate the business, evaluate the business, evaluate the business, evaluate the business processes, and then go in there. Because you can't design an architecture for a business that you don't understand how the business is going to run. I mean, you could, but 7 out of 10 times your architecture won't work. Because if I had 3 patients that came to me, I'm going to say Tyrone and Alonzo both came to me. And they both have the same haircut, right? So I say, you both have the same haircut, therefore you're going to get the same antibiotic. But what if Tyrone's allergic to one and Alonzo is not? That wouldn't work. So I'd bring Alonzo and Tyrone into the office. I would do 2 separate visits. I'd ask them what's going on. I'd go through their complete medical history, their diet, their this, their lifestyle, and I'd make 2 different recommendations. So that's what we're dealing with here. I really think if you come into the tomorrow's free architecture webinar, it's going to help you so much. And even if your goal is engineering, and your goal might be to become a distinguished engineer or a principal engineer, I think it'll be good for you to come to that free webinar too. Tyrone, pop in that free webinar, and we'll get back to some more AWS services. But I want to know you're awake, so if you're having a good time, hit the like button. Subscribe to the channel, hit the bell to be notified of new videos. Give me a hashtag, like hashtag AWS SAA. And then we will get back to the content. So I know you're awake, alert, and oriented. And I hope you're having fun. I love teaching. So let's talk about AWS Elastic Transcoder. So if the word elastic isn't there, it's probably an AWS thing. So the AWS Elastic Transcoder is going to be a cloud-based media transcoding device. It's designed to be a scalable way to take one form of video and transcode it into another form. So if you think about it, if you've ever worked with raw or uncompressed video, and I do all the time because I love making high-quality videos. And if, for example, if I shoot an 8K video of my cat Cindy, yes, I like my cat Cindy just a wee bit too much, but I like my cat Cindy. That file of my cat video, and I'm not joking, could be 50 or 100 gigs for 30 seconds of video. Now, that's not going to work for web-based streaming because nobody's going to download a 30 gig video for 30 seconds of film time. But when in the studios, that's the level they film at. That kind of detail, and then they convert it to what they need, and that way they can zoom around and zoom in and zoom out and change angles. It's really cool stuff. Always found photography and videography interesting. So, and any kind of telescope thing too. So Transcoder is going to be a system that lets you take that raw video and encode it to another form. Maybe encode it to 720p or 1080p in an MP4 file. Maybe use what's called an H.265 codec. It's a relatively new compression algorithm for video that gives you double the resolution at the same size that you might, or double the detail than you might get in a previously at the same size file. So that's what we're talking about. Now, where do you normally transcode video? On your workstation or on a video server. So that's why you typically see video editors with very powerful workstations with 1 or 2 graphics processors in there. And they typically have a big CPU, like an Intel Threadripper with like 32 or 64 cores and 256 gigs of RAM. And they can do this stuff all day long in their sleep. And they buy that system one, even if it's $7,000 for the system. They push that system for 3 or 4 years, and it's done. But if you had people that were trying to work off little mini laptops, this encoding process might be kind of challenging. So instead of doing it yourself on your local machines or servers, you could send it to AWS and pay them to do the transcoding for you. So basically, it's a web service for transcoding, and you can basically give it a preset profile, optimized for iPad, optimized for iPhone, optimized for an Android phone, optimized for a PC, and that way you can come up with various formats of your video. And because it's a cloud managed service, it's going to scale based on whatever your video files are. And it's going to give you, because it's got some built-in redundancy, some high availability and reliability. So it basically, how's it going to work? It's going to integrate with S3, and you'll store your stuff in S3. It'll take it from one thing, tune it, change it, and then restore it on S3. And it works with lots of formats like MP4 or HLS type videos. It will also give you some metadata about the video and generate a thumbnail for the transcoded files. It'll support encryption and digital rights management of your systems. And where might you use it? So you've got a media and you want it to play back on a lot of devices, smartphones, tablets, PCs. You want to optimize the quality and the file size that you're sending. You might do it for streaming videos. You might take a very high resolution movie and then push it to something that you could stream on, say, a Netflix or a Prime. You could potentially use it for video editing. So you could take a big file and turn it into a small file if you wanted. You could put some kind of watermarks in there or thumbnail generation, which could help you from a video processing perspective. Quite good from a storage and archival purpose, because you can take your storage files, which are huge, and then maybe convert them into something smaller that's going to be cheaper to store. So for the most part, how is this set up? Well, you basically set up your input and output buckets in object storage. So you go to S3, here's my input, here's my output. You do want to make sure that those buckets are in the same AWS region as the pipeline that you set up. Then you create your transcoding pipelines. You go to the management console, you navigate to Elastic Transcoder, and you create a new pipeline. You can specify the input bucket and the output bucket where your files are going to be placed, or technically objects once they're in S3. Then you configure your transcoding job. So here's your input. What do you want it to be converted into? MP4, for example? And what kind of device? Then you submit the jobs, and then you monitor them like with the management console or the API or the software development kit. So let's talk about some best practices to use with Elastic Transcoder. You really want to optimize your presets for your target devices. So what does that mean? You need to know what kind of target devices are going here. Are you sensing a theme? Learn before you do. What is the use? How will it be used? Why will it be used? Then make a decision. Manage your storage efficiently. So storage gets very expensive on the cloud, very expensive, very fast. So you're going to make sure you use some kind of a good life cycle policy. So maybe take it, keep it where it's at, then move it to, say, an S3 and frequent access, and then maybe move it to Glacier when you don't think you're going to use it again, so you don't spend a fortune on storage. You really want to monitor these things. You want to monitor your transcoding performance and adjust the pipeline as to settings anytime you need. Set up some good CloudWatch metrics and alarms so you can track the status of your jobs and the resource utilization you have. And then once you've got it done, secure your media. So these could be important videos to you. So encrypt them and make sure your media content is secure. And of course, secure that object storage S3 buckets with encryption. So I'm going to talk about VMware Cloud on AWS. And whether it's a VMware Cloud on AWS, or it's Nutanix on AWS, or OpenStack on AWS, some of these services are awesome. So VMware on AWS is an infrastructure as a service solution. And it basically gives you a software-defined data center. So picture this. the majority of the data centers out there are running VMware. And VMware is really like a cloud software. I see Mark Trimble's in that chat box. He is an expert on VMware. But here's the thing, and I showed you one of our VMware servers where we created virtual machines. So the enterprise is running on this. So now the enterprise has servers in their data center, which is the lowest cost environment, typically speaking, the data center versus the cloud. They've got a team of people that know how to use VMware. They know how to set up the systems on VMware, and everything's running smooth. And then the organization says, wow, yeah, the scalability of the public cloud is awesome. What if we were to push some of our stuff when needed on AWS and some of our stuff when needed on Azure? Now you'd think about it and say, well, now I got to train my users on AWS and I got to train my users on Azure, right? Well, not necessarily. What if on AWS and Azure, you could get access to a bare metal server, the same servers that you would buy in your data center? And you stuck the same VMware on those servers and didn't use the AWS hypervisor, the Nitro hypervisor. And then all of a sudden, you've got all these servers on multiple clouds that are speaking to your VMware infrastructure. You want to set up a virtual machine and poof, it's on AWS with using the same commands, the same everything that your team has been using for the last 19 years. That is VMware on AWS. It enables you to use the AWS network, leverage AWS services, be able to get that virtual machine scalability on demand anytime you need it, and not have to learn the AWS cloud because you're using the VMware system and they're just going to be there. So it'll use the same servers. You'll have access to vSphere, VMware Virtual Ascend, VMware NSX for virtualization technologies, and it's in the data center and the cloud with basically no training of your users. And understand, most data centers are VMware. And if they're not, they're typically running some cloud software like Nutanix, which is awesome, or OpenStack, which is also awesome. And this is where you take your data center, you install cloud software, and now you get everything in your data center that you would in the public cloud, like the ability to create a function as a service for serverless computing, the ability to auto scale out, assuming you've got the capacity in your system. So it offers a quick, easy solution for people that are used to it. So you're basically just getting you're getting bare metal systems from AWS. So very simple migration, very rapid disaster recovery, flexible dev test environments. You've got your VMware environment for your data center. You need to spin up 1,000 virtual machines, do it in the cloud real easily with capacity that you don't have. Test it all, move it back to your data center. Simple and elegant. So now we're going to talk about a tool called AWS App Discovery. And App Discovery is a discovery tool that's going to help applications migrate and optimize their on-premise applications to AWS. This service is going to reel data about and potentially help with a virtual business case creation, but it's going to help an organization think about the cost of operating in the cloud versus on-prem, the cost of migrating to the cloud, the cost of leaving the current infrastructure, the benefits in the cloud, and the cost of doing nothing. And it's only going to be as good as the information it has access to. So for organizations that are thinking about moving to the cloud, it's going to help, guide from an automated tech perspective. No, it's going to guide from an automated tech perspective. How many businesses do you think make their decisions from an automated tech assessment? How many sophisticated businesses? You think Jamie Dimon invests $1 billion in something because some tech thing says to do so? No. But I'm sure the JP Morgan Chase Bank has lots of tools, and their executives and professionals can look at those tools, and together the people that have the wisdom and the judgment and the knowledge will look at what they see, and they'll look at these tools to make recommendations to a Jamie Dimon. I picked him because he runs a very successful bank. But in reality, nobody's going to use just a tool like this and try to believe it out of this, because it's going to give you valuable information, but it's not going to be enough without the wisdom and judgment to really think things through. But it will collect information like the CPUs and servers you're using, the disk space and performance and network utilization in the data center. And it can use this data to basically help analyze and make good recommendations. So it's a good tool. The question is to know when to completely trust the tool versus using the tool. And that's the area where we architects do our job. So App Discovery will collect information and it will make recommendations on what it will think will give you a lower cost of ownership. So a little more about the migration service. It kind of simplifies the migration. It accelerates the migration because it gives you stuff that you can think of. It makes it very easy to do a lift and shift migration because basically what it does is replicates the entire server, their operating systems, applications, and data to AWS, which means you don't have to modify your systems because it does it for you. Of course, you can manually take your systems and convert your virtual machine into an AWS, Azure, or Google format and controlled tested environment. Application Migration Service does continuous data replication. So it constantly replicates the data from your source servers to AWS, which is awesome, especially if you're in two places. And it's going to make it easier to migrate with reduced downtime. It provides automated tools to cut over and test, meaning here's a tool, we tested it all, just move it. If you think a business is going to use one service like this and trust that it's going to move their $1 billion of infrastructure without lots of tests, I've got swampland. That's rare that I could sell you, but keep that on the back of your mind. It's useful. It helps. But big businesses are going to need lots of testing other than automated tests. Automated tests will miss big issues. I think we've seen some big issues quite recently. And it supports a lot of applications because what it's really doing is copying a virtual machine over to the cloud. So the application migration service is a very user-friendly environment, gives you a console and API that really simplifies moving systems over. Now let's talk about another migration service called the AWS Data Migration Service. And that's a managed service to move your databases over to Amazon. So it can support what's called a homogeneous migration from Oracle to Oracle, or a heterogeneous migration from, say, Oracle to Amazon Aurora. Or you could just launch a new database in AWS and copy your data over and make sure that your data is exactly the way you want it. But it supports database migrations from like on-premise service, Amazon databases. It continually replicates your data moving from point A to point B. And it makes sure that your target database is synchronized with your source database. It helps convert your schema. So you may have a schema that's associated with one database, and you want to move it to another database, and you're going to need to tune and configure your schema. It helps reduce the downtime and minimizes downtime between point A and point B because it's going to give you a tool to copy your systems over. It typically will help transform your data, at least basic data transformations. If you need bigger data transformations, there's ETL tools and things that can do that. And it gives you a report and monitors your systems. Okay, so we're going to briefly talk about cost management. And really, cost management is based upon your architectural choices. Meaning, if I've got a system that runs 24 hours a day that needs high performance compute, for example, a server with 256 physical cores and 6 terabytes of DRAM, it may be millions of dollars less to stick that server in my data center than it is the cloud. Over the life of that server, millions less. But at the same time, what about applications that typically run at very low utilization all year that have huge spikes around periodic times of the year? The cloud is typically much cheaper for that. And the reason it's much cheaper for that is on the cloud, you can size for what you need on average or aggregate, and you can add capacity when you need it. So I might build in a global e-commerce's website to handle 1 million hits in a minute or more in the winter, like for Christmas time. And the rest of the time, it could be dealing with 100,000 hits a minute, sitting at 10%. In the cloud, I can set it up to handle 12,000 hits at all times, 2,000 more than I need, and then set up an auto-scaling policy so I can use smaller stuff all year long and then maximize it when I need it. So that's typically when you're there. Now, when you go from a data center, you've got a capital expense. And when you go to the cloud, it becomes an operational expense. Is that good? I don't know. And what I mean by I don't know is going to depend on that organization's capital structure. In many cases, a capital expense is better than an operational expense for a business. In other business, an operational expense is better than a capital expense. So this is where you're going to need to have your business acumen. You need to understand that organization's capital structure, their weighted average cost of capital and things like that, because otherwise you're taking shots in the dark with somebody else's money. And 70% of all cloud migrations fail. There's a reason most people don't know how to do this. That's why we teach these skills to our architects. So data centers themselves typically have high capital costs in that you've got to buy the real estate. You got to bring in a lot of power. I mean, a lot of power. You could be pulling megawatts of power into a data center. You need to buy the infrastructure, meaning you're going to be on a Cisco or a Juniper and buying all your routers and buying all your switches. You're going to be buying big monster firewalls and load balancers. You're going to be buying racks, and the racks will have power distribution units. The data centers will have generators and battery UPS backups to the generators and power transformers. You will need servers and storage area networks. And of course, you're going to need to cool the systems down, which means big, beefy air conditioners. And I mean air conditioners like you can't even imagine. And these things consume a lot of power. So that's a capital expense. Now, don't think for a second that a data center has to write a check for all this stuff. They can finance it, and many do. And when you compare the financing cost to run the data center, it could be cheaper than the ongoing operational expenditure costs on the cloud. A company can also create an operational expense out of their data center tech by leasing it versus buying it. So, don't just take that certification approach. Oh, it takes you from a capital expense to operational expense and think that's good and try to tell a client that, because you'll be escorted out of the room by security fairly quickly. So you don't want to do that. So in the data center, we typically have a lot of capital, but we still have some operational expenses. And what are they? The staff for the data center, the people to manage the physical plant, the AC systems, the generators, the backup generators, the batteries, the people that are going to run to the servers and swap out hard drives for you when stuff breaks. We will need the network engineers to make sure the network's doing their thing, the security engineers to make sure the stuff's there. We also will have to pay for our wide area network connections, meaning the cables or virtual cables that we have between our locations. So most of our costs are for equipment, but other costs are for the ongoing operation. Now, in the cloud, everything changes. There's almost nothing to purchase. Almost. But you're going to pay rent on the cloud, and it is going to be expensive. To give you a cost to put it in perspective, AWS has these i3 instances. They're basically Xeon E5 2670 somethings V3s. To pull out 128 gigs of RAM on one of those things and all 48 virtual cores, it's about $1,000 a month. So to use one of those virtual machines for 4 years would be $48,000. Now you can go to Amazon right now and you can buy a server with that capacity for about $500. That same server. And you can run that server for 4 years straight for $500 plus another 150 in electric, so $650 versus $48,000 in the cloud. But do you need that server? Is that the right server for the business? How many people need to manage that server? Not a heck of a lot, especially if it's VMware. But the point is you're always going to have to do these calculations. You're going to find out that the cloud is usually more expensive, but you're going to find out that the agility of the cloud ooh, a business has this thing and we can change this on a dime in a day or a week versus months. That's worth a lot. And that can be a very strong competitive advantage on an organization. So you got to be able to look at the organization and see if that agility is worth it to them. A big blue chip company isn't going to be very agile because they're big and it's hard to get, hundreds of thousands of people to change direction fairly quickly. A little tiny company is going to be highly agile, at least if the tech supports it. Oh, wow, we see a new tool. Poof, we used it. 60 days later, there's an impact on their revenue. So we have to think about that. What's the goal? What's the business goal? What's the business need? This is not about the tech. This is about the business. But in the cloud, we have to know that things are going to be very expensive to run. And it has to be because they have to buy the same systems you do. Then they've got to run the same systems the same way you do. Now they need to hire people to sell it, people to market it, and you're dealing with tens of billions of dollars of cost to just sell these things or more for these teams. So you can start to see why cloud computing may get more money, but we have to manage those costs and we have to choose it. Choosing the right platforms, architecting our things intelligently, running them on the right systems, moving what we should move and not moving what we shouldn't move. So step one is determining if we should move it or not. Step two is only provision things that we need on the cloud because we pay for everything. And then we've got to monitor our systems. AWS monitor their systems and went, oh, wait, we're paying 9 times too much by using microservices for Prime than we are with a monolith. They got off of microservices, they got off of serverless, and they went onto a monolith. Because they looked at it, they didn't plan it right, they made a decision to use it, they realized it cost too much, and they went off of it. So imagine how much less it would have cost to design it right in the first place. But, you can't always predict what your needs are. So you could do it right and find out that it's wrong, which means you didn't do it right, and then you might need to change. So provision what you need and monitor those systems and update accordingly. Next, properly size your resources. When you build your own computer for your house, you could be cuckoo like me and say, I'm going to build it so no matter what happens, I'll have enough capacity, because I've always been in situations where you run out of capacity. So my workstation may have 64 cores in it and 512 gigs of RAM. And to be fair, an NVMe RAID array that's got 16 terabytes connected to a 96 terabyte external RAID array. Because I don't want to run out of tech. But it's me, and I like having cool tech at home, and I know I will push the tech, so I overbuild for me. Now, you can imagine my workstation probably costs a lot more than it needs to. So if I was designing a system for a business, I'd look at what kind of business they are. If they're a business that says, Mike, I need to have so much performance and capacity because 1 millisecond of latency is worth $100 million a year to us, I'd be like, okay, we're going to overbuild you to reduce your latency. And maybe overbuilding costs $30 million, but they get $100 million extra, which makes it worth it. For normal businesses, properly size your resources, which means size them for average use, not peak use, and leverage auto-scaling. It also means we can do things like decouple when appropriate. Remember when I talked about databases and I talked about putting a queue so we could use smaller, less costly database servers, pop a message in the queue, keep it in the queue until we're ready. That can reduce costs, sometimes decoupling. So decoupling the architecture may, if we decouple correctly, reduce costs. If we do it wrong, it could increase costs. So it's about knowing what we need. Next, it's about using the right platform and purchasing it. So if I'm a business and I know I'm going to go to the cloud and I know I need to keep my virtual machines for 3 years, reserve them, schedule them, and buy it with a discount for 3 years. If I need to run a batch job for 12 hours straight, and it can start and stop as many times as it needs, as long as it finishes in 12 hours or 14 hours or 24 hours, I might use spot instances, which are virtual machines that you bid in an auction-like environment. And if somebody chooses to bid more than you, they shut you down. because it's cheap for a batch job. If it's mission critical, I wouldn't use a spot instance ever. I'd use an on-demand instance. So you're going to use a combination of purchase what you need to know, scale out with on-demand instances, and potentially use spot instances. So think about, allocating the mix of what you do and knowing your needs, because if you know your needs, then you can purchase for long term with a discount. Step 4, think about the right platform. So sometimes it's cheaper to go serverless or managed service. Sometimes it's not. Evaluate all possible options. Next step, reduce the data transfer cost. So this can get very expensive very quickly. So with AWS, normally in a data center, you might have 2 different VLANs. Segregate your users from here to here and create a routing policy to route between them. Many businesses will create a tremendous number of VPCs and route between them. You'll find businesses that have 1,000 VPCs out there, which is great for us network architects. But in AWS, they charge you every time you go from one VPC to another. So if you decide to make your cloud almost as secure as your data center by chopping it into multiple VPCs, then you're going to be now communicating between your VPCs and you're going to be paying for the communication. You're going to pay when your systems grow across regions. You're going to pay for a lot of things that you wouldn't normally pay for. So manage those data transfer costs. Maybe you've got an S3 bucket in 2 places, and instead of having the request from, say, Europe come back to America every single time, if they're requesting the same information all the time, maybe set up cross-region replication for our S3. So you got a bucket in Europe and a bucket in the US, and the users only connect to their region, so they save on interregional transport costs. Now, how about content delivery networks? That can help out a lot because it can offload the work from your servers. Information can be cached locally, which may reduce transfer costs. Then we have to think about our wide area network. Now, here's the way not wide area networks normally work. You buy a connection. You pay $5,000 a month for the connection, and it's done. You've got a $5,000 a month connection. Let's say it's 1 gig private line from point A to point B. You've got a gig, and you can send as much data as you want it for that $5,000 a month. Now you got a line to a cloud provider. You pay $5,000 a month for the link. Then you pay a daily fee to have the link, and then you pay to send and transfer your data in some cases over that link. So that can get pretty expensive pretty fast. Think about that. So sometimes it's cheaper. They give you a better price on direct connections than it would be a VPN. How will you know which one to use? It goes back to what your business needs are. How much data are you transferring? When are you transferring the data? What kind of latencies can you tolerate? What kind of consistency do you need in your performance? So think about that. Now, you can also create a budget. And a budget can and can't help you optimize your costs. So I'll explain what a budget is. A budget is you go to AWS and it says, alert me when I've spent more than a certain amount. So if you set it up, alert me when I've spent $1,000, and you set a trigger at 500, send you a text message that you spent 500, then send you another message when you've hit 700, 800, and 900. It did that. Now, if you still need to use your systems, it didn't make them any cheaper, but it tells you when you're going to spend a certain amount of money. Now, you can potentially set up a budget, look at that, and this thing was way too expensive. Let's try an alternative in our architecture after the fact and redesign. So I guess it can help, but it's not going to save you money on its own. So here you've got an example. You'd set up a budget, you create and manage it, and then you're going to get notified. Hey, you spent this much money. Hey, you spent this much money. Kind of like when your spouse goes to the store and buy shoes and or whatever sporting good thing they like. We all know what it is. And then you get notified that, your spouse spent this much money buying shoes at Nordstrom, for example. It didn't make it any cheaper because you got the email about it. You still paid for it, but at least you know that somebody bought shoes at Nordstrom or Saks or wherever people buy shoes. I get a lot of alerts. So the next thing that potentially can help you with cost is something called Trusted Advisor. And here is an automated service that's provided by AWS that's going to scan your infrastructure and it's going to look at your infrastructure, which is based upon your client's needs. And then it's going to compare that to AWS best practices and recommendations for a standard customer, not necessarily your customer. And then it's going to give you recommendations. Now, it is just a recommendation. A doctor writes a prescription for an anti-inflammatory for their patient. The patient's over 40 and has high blood pressure, and the pharmacist gets 10,000 screens, alert, alert, alert. You gave an anti-inflammatory for somebody with blood pressure, and it can raise their blood pressure. And the pharmacist calls the doctor and says, do you mean to do this? And the doctor says, I have no choice. And the pharmacist says, prescription filled, and ignores the alert. These kind of automated alerts are going to be automated alerts. They provide information. You evaluate that information and see if it makes sense for you. Same way a doctor would evaluate labs on a patient and lots of different things. So, or alerts out of an e-prescribing system. So Trusted Advisor is an AWS tool that's designed by AWS to theoretically cut your spending down. And it'll look and it'll say you could use it to improve performance, availability, infrastructure costs, because it's going to give you recommendations over your deviations from AWS best practices. But you may have had to deviate from AWS best practices for your architecture. So you're going to take these kind of things with a grain of salt. Good, valuable information, but you take all the information and then you evaluate it based upon your needs and you see if it makes sense. So there's two versions of Trusted Advisor. There is AWS Basic and developer support plans where users get access to 6 security checks and 50 what's called service limits checks. And then you're going to have people on business plans or enterprise plans. So business support plans or enterprise support plans, they'll get 115 of these Trusted Advisor checks, of which 14 will be cost optimization, 17 will be security, 24 will be fault tolerance, 10 will be performance, and 50 will be something called service limits. So another tool which can theoretically potentially help reduce your costs is the Compute Optimizer. And that's a free management tool that AWS recommends to increase efficiency of their systems and reduce costs. And what Compute Optimizer does is it reviews your previous resource activity to distinguish use patterns from various use patterns, frequently or infrequently, or a stored type of data when it's accessed. It's going to look at the user's activities compared to similar activities on a resource, and it will take a comparison and give you a graphical recommendation, giving you, here's how we recommend in this automated system to tune your infrastructure. Clients are given the option to use something called the look back option to basically renew up to 3 months of history and to take that history to make gut recommendations. Compute Optimizer really enables, resource utilization, understanding to potentially help reduce your costs and improve your performance. And when a user is going to enable these suggestions, AWS will configure the resources that theoretically deliver optimal performance. Service quotas. So service quotas are going to give the users the ability to view, log, and set limits on various services. So this is going to help scale various services as workloads increase. It'll help users adjust service quota values, and they can monitor the service quotas, and they can set up limits and inform the users you're getting close to the limit. So it can be used to help control cost, optimize performance, and improve availability of resources. Now, here's a tool called the AWS Well-Architected tool. And there's a video, Tyrone, if it's easy for you to find, to pop a link between the AWS Well-Architected framework. And here's the thing. There are many architectural frameworks. An architectural framework would be, how do you approach a client for an architecture? So there's lots of them that are out there. Big companies, your big consulting companies, your biggest tech companies typically use something called TOGAF. And TOGAF is something we teach to all of our architects. And TOGAF is a standard framework. And what the TOGAF framework says, start with the customers and their executives and find out the way you want their business. Then look at their business processes, then re-architect their business processes, then look at their data architecture, then re-architect their data architecture, then look at their technology architecture and re-architect your technology architecture based upon their business goals, business needs. Set up your solutions. Here's how you build the governance structure. Here's how you build a change management. And they basically tell the architect, it doesn't provide training on architecture at all, but it tells the architect how they would approach a client in a manner to get where the client should get results from their business. So 70% of all businesses deploy technology and get no results. I'm going to say this again. 70% of all architectures provide zero benefit for the customer. And here's why. Because you got the tech people that say, we need this. And the business people say, why? And the tech people can't answer it. Or the tech people say you need it and the budget business just approves the budget. And then they spend lots of money on a tool that makes things worse, gets in the way of their business. So there are tools and frameworks like the Zachman framework or the TOGAF framework that are how you do approach a client in a manner to learn their business and design a business to get improvements. AWS and other cloud providers have a well-architected framework, and here's what they are about. How to use AWS stuff on AWS. Now, there are some good things about this because AWS is an expert on their own stuff, right? But these things are not really designed for transformation. They're designed on just making the tech work. Unfortunately, in most architectures, getting the tech to work is not a big deal. It's easy. Getting the tech to drive transformation or improve business performance, that's the real skill. So this is going to check across the well-architected tool, which is a great way to check your tech from a tech perspective. But it's going to provide no value to determine if it's going to help provide, the architecture will provide value to the business. It will provide great value if you're using AWS stuff in AWS. It gets less valuable in the multi-cloud environment where you can't use just AWS stuff and you have to use more industry standard tools. And that tends to respond better to a TOGAF framework. But there's nothing wrong with using a TOGAF framework end-to-end and taking bits and pieces of the Azure well-architected framework and the AWS well-architected framework that are more tech-specific when you design your architecture. So this well-architected tool is basically going to give you guidelines and best practices by comparing what you have compared to what AWS would put in the well-architected framework. Now, you might be doing something because you got business reasons, and this will not detect that, and it's not going to be focused on that. So please understand that. So, but it is another tool that you can use, the well-architected tool, and see if that will make recommendations that may or may not reduce your cost. And basically, you document your current state by answering a questionnaire. So all these tools are great. I don't want you to think they're not great. I don't. It's all about when you use the right tool for the right job. Tyrone, we don't have a lot more to cover, but let's take a break and see if anybody has questions. And while we're at it, if you're having a good time, hit the like button. If you're not a subscriber and desire to be, hit the subscribe and hit the bell to be notified of new videos. Any questions there, Tyrone? Well, I wait to see if you all have any questions. Tomorrow morning from 11 to 1 Eastern Time, we will run a How to Get Your First Cloud Architect Job webinar. It'll be free. It'll be on Zoom. We'll talk about the cloud architect role, all the skills that you need, the certifications that you should have to go out there and build your profile. You can ask us questions, and it's all free. We'll teach you how to skip HR, all kinds of things that'll help you get hired. And tomorrow afternoon, because we're going to finish today shortly, we're going to allocate the time that we initially planned to answer any career questions you have. Maybe you want to go from certified to hired in engineering. Maybe you want to know how to earn more in your engineering career. Maybe you want to know how to convince the manager you need it. So those kinds of things that we do. Will tomorrow's sessions be recorded? So the webinar that we will host will be given to people that have registered for the webinar and signed up for the registration form. We typically email it to the people that attended the webinar or signed up for the webinar. We don't typically put them on YouTube, although sometimes we do. But the career question and answer session, Ralph, that we will talk about will definitely be live on YouTube. Maybe I'll get in my other media studio and nice relaxed seat and answer questions. It's a bonus round, as Alonzo said. And seriously, like Alonzo said, only 43 likes. We're giving a pure AWS Solutions Architect Associate course where we're covering most of the professional, the advanced networking and security in here, or at least large components of it. If there's any other questions, great. If not, I will get into discussions on high availability. And great question. How about COBIT? COBIT is a very good security framework. And quite frankly, using a TOGAF with a COBIT is absolutely terrific. As far as OWASP, that's not a framework I've typically used in the past, so I can't comment on that. But COBIT is used in a lot of places, along with NIST and other frameworks as well for security. Would I recommend that a cloud architect should learn an architecture framework like TOGAF, or is that more for enterprise architects? Well, I went most of my life without learning any architecture frameworks, and I was just fine. So if you already know how to do architecture, then architecture frameworks like TOGAF are great because they don't teach you architecture. So here's the thing, and here's where frameworks really come into play. So both my wife and I can practice medicine. My wife spent most of her life in internal medicine and cardiology. I started in internal medicine. And then when I retired, I had a horrible injury where I couldn't walk. So I used to volunteer because thankfully I didn't need to work. I used to volunteer practicing physical medicine and rehab. So here's the reason I'm saying this, Nigel. My wife does internal medicine. So she starts at the eyes, the ears, the nose, the mouth, the throat. Then she checks the lymph nodes. Then she listens to the carotid arteries. Then she listens to the lungs, the heart. She works her way from her head to her toe. And that's what she should do for her world. I deal with physical medicine and rehab, and most problems start with the way somebody stands or walks. So the first thing I do is check the mobility of the big toe or the hallux to make sure there's 60 degrees of dorsiflexion. Then I check the ankle. Then I check the knee. Then I check the hips. Then I check the musculature of the low back, the thoracic spine, the shoulders. And I might not look in somebody's eyes, ears, nose, or throats in the physical medicine and rehab environment. But I definitely are going to look at the orthopedics piece. And the way she starts from the head to the toes and I start from the feet, the toes to the head, there's reasons for that. And the assessment that she does on her patients is going to be different than the assessment that I do on my patients because we have a different goal. Given that 70% of all architectures, and that's McKinsey's numbers, are disasters. And the reason they're disasters is people focus on the tech instead of the business goals. And that's why architects are becoming more and more businessy and more executive-y and more enterprisey every day of the week. I think it's beneficial to know a framework. Doesn't need to be TOGAF. If you work at an Accenture, Deloitte, or a KPMG, they may have their own framework. I just care that you approach every person systematically and that you know to start with the business goals. And you do. That you know to understand the business processes. And you do. Because if you design an architecture without understanding the business processes, you could damage that business seriously. So there's that. Do I like to see a TOGAF on if I look at an architect certifications and I see an AWS Solutions Architect Professional and I see a TOGAF and I see a CISSP, for example, I know there's lots of architecture related things in the CISSP, even though it's a security related thing, but it's in an architectural kind of blueprint. At least high-level architecture, and I look at the TOGAF and I say, oh, this person knows to start with the business. I'm not going to be nervous that they're going to do what they were taught in a certification, which is the name of a service, how to configure it, and here's your tech, and you need this tech without looking at the business. So as long as you're focused on improving the business, I don't care how you get there. Hiring managers per se don't care about your certifications. They care about your ability to do the job, your ability to do it well, your communication skills, your leadership skills, your energy, your enthusiasm, your passion for the job, your willingness to go above and beyond, you being a team player, and how do you actually add to the team? What is it about you? But the competency piece is key. And one of the reasons I started using TOGAF was so people actually understood architecture was not engineering. Because I had people that wanted to learn to code to be an architect. And they would spend 6 months learning to code, and they'd say, Mike, I'm struggling. I'm like, yeah, we told you not to learn to code. We told you to learn this, this, and this. Now go back and do what we told you to do. And at least when people see a TOGAF, they don't think they're going to learn architecture by learning Linux or Python or SysOps or DevOps. It keeps people focused on architecture, which is designing systems to optimize business. But do I recommend cloud architects getting it? I recommend 2 to 3 certifications for an architect. And if one of them is related to an architecture framework, I tend to like it. We'll talk much more about that tomorrow in the How to Become an Architect webinar. And that's a very good question. So give me a hashtag AWS SAA, and we will get back to the content. So let's talk about designing high availability systems. And we'll talk about what does availability mean. And honestly, in a certification, we don't have the time to talk about this. I spend hundreds of hours with my architect clients, students in our cloud architect program teaching them this. But let's give you some good pointers. Availability means the system is there when you need it. So if you go to dial 911 for emergency in the US or say 999 in the UK, and the phone doesn't ring, you've got a problem. Because the system is not available when you need it. So when it comes to availability, we typically talk about in nines. 99%, 99.9%, 99.99%, or 99.999%. Some systems need to be 99.999%. Air traffic control. Are you serious? That stuff goes down, planes start falling out of the sky and crashing into each other. That needs to be up. And a healthcare system. We need a high availability system because when those systems go down, people can die. In a bank, a minute of downtime could be $50 million lost or $100 million lost at the wrong time. So we need to keep those systems up. By comparison, one of these days, I'm going to start a My Cat Cindy website. We're going to have photos of my beautiful cat Cindy. And photos of her wearing silly things like T-shirts, photos of her eating her favorite Purr Pops and her favorite snack because she's cute and I like my cat. Now, if that website goes down for 10 minutes, so what? Nobody looks at photos of my cat Cindy. So we have to understand the business needs. To put it into context, 99.99% available is what many organizations would consider high availability. That is 52 minutes of downtime per year. That is a lot of downtime. A 99.999% available system is 5 minutes and 15 seconds of downtime. My entire life has been spent building 99.999% available systems because I've been put on the world's biggest projects. But many businesses will tolerate 4 nines, and most businesses could never get to 99.999%. And it's not going to happen on a single cloud. And whether you can get to 99.99% on a single cloud is questionable. There's been many years where the cloud providers couldn't do it no matter how many regions and availability zones you use. And there's been years where they've done just fine. So what does it take to build a high availability system? The first thing is no single points of failure. If you're only on AWS, AWS is a single point of failure. Can you build moderately high availability systems on AWS? Absolutely. Because they're a great company. They've got expertise in running their data centers, and they're real good at what they do. But, they've had their power failures, which took down the entire cloud for half a day. Azure's had their failures. Look, Google's cloud, somebody took it down with the BGP misconfiguration. Somebody at Google deleted a $240 billion hedge fund. But that's why when you put your systems in somebody else's baskets, you need more than one basket because you don't know what they're going to do. So I hope that makes sense. The next thing is power. You need redundant power. No data center that I've ever worked with, except for AWS, has ever seen a power failure. Why? You bring in two power companies into a data center. You then have different transformers. You then have backup generators, and you typically have battery powers or backup generators. So data centers don't have power outages. AWS claimed that one of its multi-hour power failures was due to a power outage, which is possible. It really is. Maybe they had a power management system, as they said, which didn't work. But again, single cloud, single point of failure. So no single points of failure. That means multiple routers connecting to the cloud provider. That means multiple links. That means backup paths in your routing protocols. That means not one server, but two servers. That means your routers aren't plugged into a single outlet, meaning like a single power distribution unit where they're good for, say, 30 amps at 240 volts. And you hit 30 amps and the circuit breaker blows and it takes down that. So multiple power outlets, multiple power distributions, multiple power circuits. It means when you get a link or a direct connection to AWS, if you need a direct connection, you have one on AT&T and maybe one on Verizon. You don't put two links on AT&T because when AT&T goes down, you go down. It means you don't have a single router connecting your AT&T and your Verizon link to the cloud. Use multiple routers. It means you leverage load balancers and multiple load balancers to load balance across multiple systems when some goes down. It means your DNS is there. It means your storage area network is using some form of RAID. It means your applications are redundant. And it also means that you don't allow Billy Bob to make a change on the system without going through a proper change control system. Because it doesn't matter how good your design is, if you allow somebody to push new code or go configure the network or change the routing during production time without assessing all the value. What happened with CrowdStrike? Somebody made a push and they pushed it out, and other high availability systems which were designed properly all went down because these organizations trusted somebody else. Now, was their architecture correct to trust somebody else? Absolutely not. Now, if they did trust somebody else, what was their backup things and how did they do that? And if they did that right, architecturally wise, it wouldn't have been such a problem. So here's why it should be easy to design high availability in AWS. They maintain redundant power until they don't, like the power failure. They maintain redundant cooling. They have redundant connections to so many different internet service providers and wide area network providers on their background. They have highly redundant routers and switches. And they know how to build a data center. So they have good practices, good change control as a rule. It's very easy for them to design a high availability system because that's their expertise and they're good at it. Now, understand their data centers may or may not be quite as high availability as other data centers if they're managed equally well. And the reason is AWS and Azure and Google and everybody else are hyperscale, which means they have to deal with a tremendous number of providers' traffic. They need to deal with a tremendous number of customers. And there's more things to go wrong in one of their data centers, and there's less security type things they can do. They can't run quality of service. They can't do certain networking things for the average user because they don't know the user's traffic. But they are experts at what they do, and they are incredible at it. So according to how to pass the exam, if you want 4 nines availability or 99.99% availability, put your stuff into availability zones. And unless AWS has a network failure, a major hacking event, or a control plane failure, you'll be quite fine. But we've seen these issues happen taking down multiple availability zones. So at minimum, use more than one availability zone or more than one data center. Now, if you need more than 99.99% availability, use another cloud. But for the exam purpose, just use 2 availability zones in 2 regions. And that'll work great unless there's a hacking event, a control plane failure, or a network failure. And then you're going to lose both regions and you're going to lose all the availability zones. So don't do that. But at least for the exam purposes, please know that. So anything that's important should be in either multiple availability zones or data centers or clouds. So virtual machines, databases, load balancers, DNS, that sort of thing. Redundant network connections. So you're going to need multiple connections. If you need 40 gigs of guaranteed bandwidth to AWS over a link aggregation group of 410 gig links on Verizon, you're going to need 410 gig links as a backup, most likely. And it could be on an NTT or a CenturyLink or an AT&T or any wide area network provider as you want. Most organizations are going to be fine with just a direct connection and a backup. We're two different internet service providers and two different VPNs, but it depends on the organization's needs. But make sure any connections to wide area network providers are on different connections, different service providers, and you're going to have to really look into the fiber optics and the copper coming into the building. There could be a conduit under the ground where an AT&T and a Verizon cable all go through. And here you think, oh, I got two different internet service providers. I got my router on AT&T and my router on Verizon, but they're in the same fiber channel under the ground, and then a backhoe dings under the ground and digs up the fiber, and you've got lose both. So when we network architects look at these things, we need to look at the fiber coming into the building. And are they under different conduits? Do they have different fiber paths? Do we have redundancy in our paths? So think about that. Now you can see why architecture isn't really things that are really covered in the certification. It's looking at every detail. And if you can imagine, you've got to look at fiber paths coming into a 500 building, and you've got to look at the IP addressing plan for 1 million users. And you've got routers with 10, 15,000 routes in the routing table, and you've got 14 internet connections, and you've got 2 petabytes of data, and you need somebody to design your AI and somebody doing some data science stuff and somebody designing your IAM and somebody designing your security. I hope you see why architecture is a team sport. Part of high availability is good security. So that means using the principle of least privilege with regards to your IAM. It means locking down your servers and getting rid of unnecessary services. It means patch your servers with updates after you've tested them. Don't just patch them. It means limit the blast radius of problems by using AWS organizations and separating various parts of the enterprise, or creation of multiple VPCs and route between them. Use next generation firewalls and IDS IPS systems to have really robust security. Keep unwanted traffic out of subnets with a good access control list. Use good security groups. Use good endpoint protection on your devices. Provide good physical security so you can have done everything I talked about, and I can leave a network port over, and all I need to do is plug my PC into the port and I get on. So maybe some form of a MAC address authentication. So if I plug into the network and I don't have the right MAC address, the port gets shut down. Making sure you've got physical security, making sure that people can't access the room where the routers are. Lock that stuff up. Use good passwords and template good configurations with some form of infrastructure as code like CloudFormation or Terraform. Back up the systems. Consistent backup strategies will prevent data loss. Data loss protection strategies will also prevent against data loss from a security perspective. Create images of your production servers. Add auto scaling into your system. So we're getting hit with a DDoS attack, and you have auto scaling, and it increases the capacity of what you have. If we decouple various components in our architecture, like the database and a queue, we can store messages in that queue to help our systems be up and running. We can cache information. If my photo of Cindy is on the cache in Athens, Greece, or Istanbul, Turkey, for example, and my web server goes down, but a user in Istanbul can go click and still get my Cindy the cat photo because it's cached there, I increase my availability. Use a strong DNS system. So have multiple places that are endpoints that DNS can point to. So if one goes down, you got another. Use load balancers because they enable you to share the load amongst multiple devices, removing single points of failure. Use good, strong logging and auditing functions so you can see what's going on. Did how the hacker make a change, and how do you revert it back? Constantly take your logs and aggregate your logs. and look for system alerts, maybe a SIEM system in here. Constantly monitor for security breaches, because if the systems are hacked, they could be down. Monitor usage, manage performance. Change management. If you allow Billy Bob to make changes at 9:30 in the morning in a financial firm when the market opens and it's going to have the most traffic, that's going to cause big problems for the bank. But if Billy Bob just said, I'd like to make this change, and then that change was sent to all the key stakeholders, the people that lead the application team, the people that lead the traders, the people that lead to this business, the people that lead to this business, the people that lead this business, all those stakeholders can evaluate the change and say, well, this will help, will not hurt our system, so it's okay, but it's okay to happen at this time. 2:00 in the morning on one day of the month when it's a leap year, when the bank can actually afford the downtime, but that's necessary. So all stakeholders have to approve a change. The change is made, and all stakeholders have to make sure the change is tested and everything's working. So this is kind of what you need to talk about. So I'll briefly talk about passing the exam, and I'll take questions. There's nothing, this is not a complicated exam, but it's going to be challenging anyway. And here's the reason why. Questions are going to be asked in a way that can pretty much pull anything from this curriculum. I mean, any kind of minutia detail point they can find is typically something they tend to look for. So if it's not that complex, but you want to make it challenging, they're going to do that. So it's somewhat challenging, but it's not the content that's challenging. It's the way the questions are asked. So because I said it's the way the questions are asked, get used to answering the questions, i.e. get a practice test. The way AWS writes the questions, they're very wordy. There may not be a clearly great answer, but you'll choose the best answer. Now, I want you to think about this. If you've been in tech for a long time, this is going to be a very hard exam. If you're brand new to tech, it's going to be very easy, and here's the reason why. Associate exams are intro-level exams. So when they give you this exam, it's going to be from the perspective of an intro-level person, which is what you just learned in a certification course. It's not going to necessarily be what people do in the real world. So there's this guy, Mark Trimble on this session. Mark's got 45 years experience working with this technology. He knows this technology in, he knows this technology out. You get a guy like him taking this test, and he's going to say, what did I know when I just started out in technology? Because that's the real answer. So if you've got a lot of experience, pretend you don't, and think what an intro-level person would do. If you're brand new and you don't know, it's going to be very similar. So those are recommendations I have for you. Here's what I recommend. We went way above what's covered in the certification. We also have a completely free book on passing the certification, which you can also download. I recommend you read it. Certification exams, part of the reasons is to give you technician level knowledge, but also to get you excited about the vendor's technology. They want to get you to love this stuff, because you love it, you're more likely to recommend it. So where do they get these recommendations that are coming from? Well, the white papers. White papers are what company writes, and architects write them all the time to try and influence an agency to buy your stuff. So if you're dealing with a test that's designed to make you like a certain vendor's technology, and all vendors do this, read their white papers, because you're going to see a lot of the exam questions on there. So go do this course, go read our free ebook, take this course a second time, get a practice test, maybe do some of those hands-on labs, even though this is more of a brain thinking exam than an actual doing exam. There might be a couple questions you could get better by practicing it. And then the day before the exam, take it easy. This is not the time when you spend all night studying. Why? Because the questions are written in a very weird manner. So you're going to need every little bit of noodle work you have to be able to understand those questions. So that means the night before, get a good night's sleep. If you like scotch, don't drink it the night before. Get a good night's sleep. Instead of eating that steak, that filet Oscar, and some kind of a beautiful potato with all kinds of butter on it, and drinking, 2 glasses of wine and having some scotch with your friend, eat some chicken and broccoli or whatever you're capable of eating that's healthy for you. Eat something that you're going to feel good with and go to bed early and get sleep. Arrive early for the exam. Seriously. I will tell you that more stuff is going to go wrong. If you do it from your house, your computer will crash or their computers will crash. So think about that. You don't want to be in that position. Give yourself the time. And, check. I like to frisk myself before I leave the house. Do I have a wallet on? Or a watch on? Do I have a wallet on me? Do I have any necessary tools that I may need to for my daily living? To make sure I have it. So check yourself. Make sure you've got your ID. Make sure you've got everything you need. And if you're going to take this test in a big city, allow time to park. And don't forget your photo ID because you won't be able to take the exam in most cases. So that kind of concludes the AWS Solution Architect training we did here. I can take some questions for a few minutes. Keeping the cloud costs in view for organizations to have high availability systems on cloud or have their own remote. So I'm not sure I completely understand the question. If you're saying from a cloud cost perspective, should you have your high availability systems on the cloud or redundant data centers? It really doesn't matter. All a cloud is somebody else's data center. Now, you have more control in your data center than the cloud. Here's an example. I advised a bank many years ago that they should run something called quality of service on their network. They were dealing with unified communications, IP phones, and we said, you need to run quality of service. You need to prioritize your voice first, then your mission critical traffic, and then everything else. The bank kind of laughed at us and said, we have gigabit Ethernet to the desktop. We don't need that kind of benefit. And I said, from a security perspective, you will need it. Well, here's what happened. 3 months later, they didn't put the quality of service on the network. A worm hit their network, and the worm generated full gigabit Ethernet traffic on every single network port. And basically, that worm traffic took the entire network down and all the voice systems down. So not only could the traders not make a trade, but they couldn't even call anybody unless they used their mobile phone. Now, had they had quality of service, their voice traffic would have gone through at all costs. Their next traffic, which was their mission critical traffic, wouldn't have got through. And the worm traffic would be regulated at the whatever's left over. So that wouldn't have affected them. Now, when we go to the cloud, they can't do QoS on our traffic because they don't know what our traffic is actually going to be. So we lose a lot of these things. We are also at the mercy of other people doing what they're supposed to be. Do we think CrowdStrike did what they were supposed to? No. Poor QA practices. There were a lot of failures that occurred there. CrowdStrike is still a great company. The point is no matter what, no matter how good you are, things are going to happen. So you should design around it. So you could build 2 data centers separated over a distance and really lock them down and have the right policies and procedures and make them both 4 nines data centers. You could do it. Or you could have your data center and you could also be 50% in the cloud. In your data center and the cloud and 2 availability zones, you still have high availability. Or you could have 2 availability zones on AWS and 2 availability zones on Azure. With the high availability DNS situation, maybe you go to F5 and buy your own DNS servers and you put them in all clouds. That works too. So the real question is, what is the actual needs? But I would tell you, I probably wouldn't use a single cloud for many systems. And to be fair, 98% of organizations don't. So hope that helps. But you could do it either way. And I don't think there's one that's better. In terms of cloud costs, it's probably going to be more expensive in the cloud in most cases. But that's going to depend on the utilization. David Lithicum numbers are really good since he saw so many of these. And he said the cloud is typically 250% more expensive than the data center. That's in line with what I've seen, but I've done less statistical analysis on it. But you've got sporadic traffic loads, that cloud's a lot cheaper. And even to be fair, which is better, saving a little money or having agility? If you've got a small and nimble business, oh, wow, there's this new AI tool and they can implement it in 3 months versus, manually making it themselves in 18 months. Maybe that 3 months versus the 18 months gives them 15 months of speed over their competition. Maybe that means a big return for the client. And maybe cost becomes irrelevant at that fact. Maybe it's worth paying more for speed. That's why people used to pay, $5,000-$10,000 to take the Concorde from New York to London, as opposed to a standard flight, because 2 hours is a lot better for 5. And if you're dealing with the CEO whose average time is worth $15,000 an hour, it might have been worth to take a plane like that. Because if they could save 3 hours of flight time, they could generate $45,000 of return on their time, as opposed to, thinking that they spent $3,000 or $4,000 more for the flight. I hope that makes sense. Good question, though, VJ. How do you do an interconnection in a multi-cloud architecture? So, unfortunately, I can't really teach network architecture here like I can in my 800-hour cloud architect program, but I'll give you some options. Option 1 is you'd use a VPN, and you'd put a VPN concentrator on both clouds and you connect your systems. Option 2 is you use a SASE type WAN solution or a software-defined WAN solution. A common SASE solution to do multi-cloud could be something like an Aviatrix solution. There are other SASE solutions as well that could work, but that's one that's pretty well known for the cloud. You could use Cisco or type of a software-defined WAN environment too, but Cisco's not the only people that make it. So the real key when you're doing these things is making sure that you understand your CIDR ranges for each one, creating the tunnels that you necessarily need, and setting up BGP in a manner that the routes and network layer reachability information that you need on one cloud is reachable on the other cloud and vice versa, as well as also making sure that if you're in AWS and Azure, and you connect these two via a connection, your VPCs or VNets or what have you, same thing, and AWS gets hacked, Azure will be hacked through that connection if you don't do that connection right. And if Azure gets hacked, the hack can go into AWS. So how do you firewall off AWS and Azure? How do you architect that? That's, again, a network and a security question. So you can definitely do it. And it's not that complicated, but it's something that takes, learning networking and learning security. And it's a great question, Phil. Maybe we'll do some networking things, me and Mark. I love talking about networking. Okay, so we finished today. Join us tomorrow. We got a lot of career-based things. And that morning from 11 to 1 Eastern time, we will discuss getting your first cloud architect job, your first solutions architect job. I'll talk about it, how I started my tech career and what I did wrong and the lessons I learned. We'll talk about what we actually do in the role. We'll talk about the skills that you need. We'll talk about why you need to skip HR or auto so you don't get auto rejected, and we'll tell you what to do instead, and it's going to be free. And again, in the afternoon, around the same time we were going to do this at 2 p.m., we will come out there and we will answer other questions. Maybe you are interested in enterprise architect careers, AI architect careers, cloud engineering careers, network engineering, offensive security engineering, defensive security engineering, security architecture, and we'll give you any guidance we can to help you get to your goals. I hope you had fun. I hope you guys learned a lot. We have some other related content that's coming out for free. We will email you as soon as we are able to do that, but that's also coming up as well related to this content. And I may have some other free stuff for you too. So please subscribe and hit the bell to be notified of new things to help you in your career. If you've had a good time, please give it a like. Renato, I am always so appreciative for your kind words. I know you're over there in Canada via the Philippines, and I'm seeing how much you're learning all the time, and it is such a pleasure to see something like that, and thank you so much. Take care, everyone.